Okay, I'm sure are you able to see my screen, right?
Yes, sir. Yes, sir.
Okay, just a minute. And okay, yeah. Uh, so again, welcome everyone. Let me see whether my video is on or off. Okay, just go back here. Okay, come back to this. All right. Okay. I think we're good, right? Cool. Uh, so again, thanks again for taking time and joining the session on the afternoon. I know afternoon sessions, especially afternoon, uh, it could be many things where people occupied. It could be work, or it could be, though it is a Saturday, people have their own plans as well. But again, I appreciate you all for taking time and joining the session. Uh, so just want to, tell a few things before we get into session. So I just want the session to be more interactive, meaning that uh, I might ask some questions in between, or you can stop me at any point of time if you have any questions or anything, so that we make the discussion more interactive, so that it might help all of us. Right. So feel free to stop me at any point of time and ask questions. Again, there is no small or big or silly questions. So we all are here to learn ourselves and, get to know things and improve ourselves. So there is no such thing exist in this process. So just feel free on this one. Okay. Just some quick short introduction about me. My name is Kalyan Prasad. I think as Mahesh mentioned, so based out of Hyderabad, India. I lead AI and data science teams at the moment with one of the startup-based companies. Uh, so over to more than a decade of year experience that I have in the industry, where have solved different domain problems throughout this experience. So coming to academic background, again, I'm not a typical computer science background guy. Rather, I have an engineering degree. So I came from commerce and finance background, and from there I switched my career into technology. Right, so I transitioned my technology to data science and AI on my own, and now that's been quite a years that I've been actually working in the industry. So other than that, I balance both industry and academia, meaning that so full-time profession I do, and other than that, on the academic side, I teach in one of the global edtech platforms on different programs for AI and data. Again, where I teach to people from uh, the experience who are getting into this field, and also to the leaders who wants to understand this technology in various domains. So at the moment I am like actively working and helping on the AI in healthcare to some of the leaders. That's what I do. So other than so I'm a big open source advocate. So I lead India's biggest open source community at Hyderabad, and I actively advocate the open source ecosystem, not only in Hyderabad, India, across the globe as well. So I actively contribute to the open source ecosystem across globe through by giving talks at various forums and by helping the open source community in various ways, which I do. Other than that, just I spend my free time in traveling. I'm a big travel freak, so I love exploring different places, and I kill all my stress in gym, and I just watch movies to just relax myself. So that's very high level and a crisp intro about me. All right. So let's get into the context again before we get into the AI in automation and also robotics, right? Let's understand. So we all do, right? For example, we laugh when AI actually gets confused. I think this often happens, right? For example, if you are using any tools these days, there is a high possibility where AI get confused at some point of time. But what happens when AI acts instead of it talks, right? So that's what we've been seeing now. The switch is happening. So meaning that what I want to convey here is, so we are used to AI misunderstanding us, and which is actually fine because you don't have full clarity on us, which is absolutely fine. Again, nothing serious happens if AI misunderstands us. Okay, that's totally okay. But today, what we are seeing is AI is moving beyond conversations into machines and robots and real world systems. And so the once AI starts acting on these things, the rules keep changing it. So that's how the whole switch is happening now. That's what we'll be seeing more in the next 1 hour, right? So again, let's kick off session slightly bit fun here. I think if you look at this image, right, the image is basically showing a robot vacuum. So this is basically a robot vacuum cleaner. Okay, which looks slightly stylish here because it has some sunglasses. Again, it's just dodging the socks as it's cleaned the living room. So it's basically trying to clean the living room and also parallelly dodging the socks here. And if you also clearly observe, there is a speech bubble on top of this vacuum cleaner, and it says that world domination, whether the robot is trying to dominate the world or it just says that now I'm just cleaning up things. So what does is basically this image means is that so when we talk about AI and robotics, it's easy to imagine the futuristic scenarios where robots take over the world. So this is what we've been hearing that AI will take over the world, robots will take over the world. So there will be no human existence in the future. This is what people keep talking about it. But
Brilliant, sir.
uh,
Are
yeah,
not the slides are not moving.
okay. Is it moving now?
No, sir.
Just a minute. Let me stop share scaring. Here we go. Okay, share. Is it moving now?
Yes, sir. Yes, sir. This part was you completed this part yesterday, sir.
Yeah.
Yes, sir. This was completed yesterday. This one.
Yeah.
Okay.
So, yeah, is it visible now?
Yes, sir. It is visible now. Yes, sir.
Okay, okay. So, yeah, I was just talking about this part. So what I was saying is, so there is also a belief that AI and robots will take over the world. This is what people believe it, but it's not like that. So most of today robots are focused much more on practical and sometimes like hilarious tasks. Like for example, if you look at this image, avoiding socks and keeping our home tidy. This would uh, do. So to conclude this, so it reminds us that AI in robotics is already part of our everyday lives, often in a way that are helpful, approachable, and even a little quickie as well at sometimes. So now, as we dive into the world of AI in automation and robotics toward this session, right, for the next 60 minutes. So let's just keep in mind that while the technology is really powerful today, And of course, there is no doubt in that. So it's also here is to make our lives easier, and also maybe gives us a laugh along the way, like more exposure along the way, but it will not like completely destroy or replace things. Okay, completely. This is something you should all remember. Now, right, the shift from digital AI to physical AI, right? So far what we are seeing is basically the traditional automation, which is like, where we have a classic rule-based systems, or like, static workflows. Uh, mm, Static workflows, just a minute. Okay, I think sorry for the trouble. Uh, Again, just want to remind here, I think people who have already, I think, joined this session yesterday, I think for them it might be a little repetitive here. But again, so I think if you again trying to understand more in detail, I think that will be a like, kind of a recap session for you all. But happy to hear if you have any further questions on this. Right. So what I was talking is, so we, especially on the traditional automation side, we are pretty much on the rule-based and the statistic workflows, which mean that all these things really work well in the controlled environments, because traditional automations are pretty much on the controlled environments, but it really struggles with uncertainty and also variability. So if there is anything changed or any uncertain things happens, it will definitely get stuck. So that's where traditional automation is today. So the switch now is towards moving to physical AI, which means we are in a environment where we are able to adopt things. We are able to self-correct our systems, which means that it improve with the experience, and pretty much handle all the edge cases, and also recover from the errors, like autonomously, like everything learn through on its own. uh, so the overall impact that we are seeing is at the moment is 25% productivity in the existing things, which means that, for example, if we talk about logistics and manufacturing here, so AI-driven robots are trying to reduce the downtime and improve the accuracy, and also the optimizing the end-to-end our workflow systems. So the milestones for if you look at 2026 and also beyond 2026, right? So humanoid robots will be coming to picture, where we are moving from a stage of experimentations to directly deploying them in a real world systems, right? Because the hardware costs are falling in place, and we have a better foundational models these days. We have a lot of very good foundation models, which makes this transition more viable and also more realistic. That's where we have been seeing the shift happening. Again, when people talk about AI and robotics, so a lot of times what I've seen personally is people often get confused, and also there is a belief that people assume that both are same, like both do the same sort of things. But there is slightly a thin line between the robotics and the AI, the way they do things. For example, they are closely linked. Of course, there is no doubt in that, but they are purely distinct fields with separate objectives and methodologies. So what I mean by that is, so for example, robotics primarily focuses on the physical aspects of a machine, like designing and building hardware, which performs like different specific tasks, right? For example, drone delivering packages, all those things can be done by robotics. Right. So all these systems, when we talk about robotics, right? So these are primarily rely on a programmed instructions to function, like they are already pre-programmed functions that follow set of instructions. On another side, when we talk about artificial intelligence, it's purely the brain behind this intelligence systems. So again, it involves a software capable of a learning, and it also has this reasoning capabilities and make decision abilities that allow the missions to respond dynamically to the changing conditions. For example, if you see, right, so today, um, uh, chatbots in different applications, right? So they provide more personalized support in their environment. Either it could be banking, or either it could be in other phase, right? So they do pretty much great job. Now, what happens when we combine both AI and robotics, right? So this is where the whole systems becomes more advanced and more intelligent, which means that what we are trying to do here is we are trying to blend the physical capabilities with intelligence so that AI powered robots can uh, do some amazing things. For example, they can perceive the surroundings through, and also they can process the data in real time and make more informed decisions. And this will make the all the essential industries that require the precision, adaptability, and also the autonomy part. That's where the whole focus is happening now. Again, these are some of the technologies that we actively leverage when we are trying to build the automations, leveraging AI and also the robotics, right? Primarily, firstly, computer vision. I think computer vision is there from like long back now. Now, along with computer vision, the VLMs are joining the race, like where we are leveraging both computer vision and VLM. So now these technologies are allowing all the robotic systems to, the detect the objects or interpret the 3D environment and understand all the visual cues. So all this will happen when we combine the vision with a language. So the VLMs are nothing but a language models, which means that along with the vision, you are also trying to combine the language for richer context, right? So that's where the whole things will make more robust here. For example, in if you take any of the now, for example, in manufacturing, right? So the computer vision, all the systems, right? So they are used for all the quality control checks, and most of the robot arms are equipped with a camera, inspect products for defects on assembly lines and all, right? So that's what thing. And from one very realistic industry example is if you look at the BMW, right? It basically uses the AI-driven vision systems to detect the imperfections in all the car bodies before they leave the factory. That's what do. When we talk about machine learning and deep learning, again, how these helps in robotic and automation systems is because of these techniques, right? So the robotic systems and also automation workflows learn from the data, and they try to adopt all the new tasks and make a more intelligent decisions, including reinforcement learning. So reinforcement learning is also a part of a machine learning process, in which where the autonomous agents learns to make the decisions by interacting with the environment. So in most of the reinforcement learning process, right? So autonomous agents learn to perform tasks by the trial and error method, especially in the absence of any guidance from a human user. And that's how the whole process works here. And edge computing and NPUs, again, this is where the world is more going now. It's kind of a distributed framework that which will basically brings the enterprise applications closer to your all the data sources. So for example, the IoT devices which generate the data continuously, like for example, it generates the data every minute, every second, or local edge servers where it come continuously generates the data. Now today, if we look at the edge devices, right? So all these robots, sensors, and autonomous vehicles produce, and they act on more than half of business data at the source rather than in the cloud, right? That's how it is, and with all this, because of this, it enables more realistic or real-time decisions. So the data volume these days is driving a very huge demand because of all the processing, right? And also, as a result of this, like a dedicated AI hardware system is necessary. That's where the NPUs, which is nothing but the neural processing units, are seeing a rapid market growth, scaling from hundreds of millions of the dollars in the next decade. That's what we'll be seeing it. Again, if you want to understand more on the edge computing NPUs, I suggest to go and read some of the NVIDIA blogs, and also, for example, try to listen the recent keynote of NVIDIA Hansen, where he really talked about what's going to be the future on these things, especially on the AI systems. NLP, we all know we've been using NLP, I think, more than a couple of years now. NLP is there everywhere, in even in our mobile applications as well. So it basically try to understand and respond things in a human speech, right? So in terms of a robotics also, this enables robot to understand all the natural language and also try to respond in a more human language, so that the seamless human robot collaboration will happen. So as I mentioned, so the down the line, the future will be more about the collaboration between the systems and human. It's not something like systems will do everything. So the collaboration between the human and systems will make things much better. In terms of predictive analytics also, so we see that where AI and also our automation workflows helps us to forecast how our equipment failures happen, like how often the equipment. So it gives us an idea that when it's a case where equipment failures might happen, or what is a period that where I need to optimize my maintenance or minimize my downtime, right? So all these things will help with the help of a predictive analytics. And now that finally we are moving into the era of agentic AI, right, where we are trying to self-correcting systems that can make autonomous decisions and execute our workflows within minimal human oversight, which means that systems are able to perform wide range of a task with a very less human intervention. So now that's what we've been seeing from last year, that the evolution of agentic AI is much more, and it will become more robust in 2026 and also the upcoming years, where a lot of applications will be deployed, and we'll see a lot of things happen in the real time. At the moment, I think the numbers are very low, especially if you look at the agentic AI production level applications. So that's what the statistics also talks about, because we are very good in terms of building the POCs or initial experimentation, but when we're actually trying to move the systems to the production, that's where it's failing because of multiple reasons. It could be the our LLMs are not data readiness, or we need to do sort of a reverse engineering to understand the organization workflows, right? Understand. So the problem is not at all with the technology. The problem is within the systems, like in the organization workflows, where we need to understand the pain points, understand the problems thoroughly. Then we can uh, plug this technology and make things much better. And the role of AI in robotics, because these are the five things that play a very major role in the robotics, especially, right? Because AI is transforming the robotics by infusing more cognitive intelligence into the mechanical system. So that's what I told the physical, blending the physical systems with the intelligence. That way we make things much better. So now, when we combine this, right, so it allows the robotic system to act much intelligently, adapt to the changes, and also collaborate efficiently with humans. Right. So on the autonomy is more about again we are trying to enable the systems to perform tasks independently, if like say from navigation to problem solving, without the constant human control, like very minimal human control. That's where the systems has to perform autonomously on the task. Perception again. So AI helps the systems interpret the sensor data. For example, it could be a visual or it could be auditory inputs to understand the surroundings, right? So it perceives things and it interpret and act accordingly. And adoption. So again, machines allow, or let's say, for example, machine learning allows systems to learn from the past outcomes and adjust the behavior dynamically. And when you talk about reasoning, even the systems are in a position now can make informed decisions based on the logic and on the data analysis that they do, and also the situation awareness. For example, I'll give you very realistic reasoning. If you go and type something in the chat GPT, right? Before it answers to your question, there is a pop-up that you see that it's doing some reasoning, which means that it keep trying to analyze it before it gives you a more realistic answer, right? The reasoning is something that is trying to that system is performing within themselves. Then it's keep trying to give more appropriate response or a relevant response to the question. So this is something I'm sure you all witnessed it, right? And interaction, most importantly, right? So the system and for example, AI systems and also the emotion recognition enables this robotic and systems to engage naturally with humans. So this will improve the collaboration and also the accessibility in the systems. Okay, and so these are some of the industry application that we'll be seeing in the next few minutes on the manufacturing smart factories. So this is the whole ecosystem of the connected factory in action, where we are seeing the it's a four layer here, where we are looking at the innovation, we are looking at the agility, how it is taking the concept from concept to implementation, and from implementation to the risk that we are encountering while doing it, and also the efficiency. So what we are trying to do in this process, in the connected factory is trying to convey, is especially in the manufacturing and smart factories context, right? So AI powered robotic arms are trying to automate the assembly and welding here. So if you look at the process, so we are trying to automate this assembly process and also the welding, which is trying to improve our speed and precision, right? So how we're trying to, so this is where the computer systems enable the real-time detection and also the quality control. So we are doing this, but the vision systems are here to enable our vision systems are here able to detect any if there are any detections or during this process, so through the quality checks. And on the other side, the predictive maintenance is trying to reduce the downtime and cost, because there's a lot of process which is not manual intervention, which is where the systems are doing. Your AI powered robotic systems are trying to do it, right? For example, this is where BMW using the AI-driven robots for all the assembly and also the quality checks in their smart factories. Warehouse and logistics automation again, and we see a lot of a big intra or like big ecosystem in the warehouses. Like warehouses are like very big, like more than size of a palaces, right? So here, what this image is trying to convey, or this the context we are trying to understand here is autonomous mobile robots, which has the transport. For example, we call it as AMRs here. So what they are trying to do is this mobile robots transport all the inventory. So if you see this, all these are mobile robots which are trying to transport the inventory, like moving from here to there, and also the all the inbound automation is happening to technique called depalletizing, which speeds up the all the goods handling process. And also the if you see this one, it's like vision based inventory management system that is conveying that accurate stock levels, like so like with this process we are able to clearly get to know that what kind of a stock, how much stock we have, whether it is accurate or not. Now this whole process, what we are trying to get out of it is we are purely seeing the productivity, right? So because there is a lot of automation and AI systems which are in place, and which is boosting the productivity in the logistics ecosystem. The reason, so the same, let's imagine if the same process has to be done manual, it takes a lot of effort. Of course, there is a lot of human intervention involved, a lot of human effort involved in order to move things, in order to speed up things in terms of either good handling, or either in terms of a transport inventory, or either in terms of evaluating the quality checks of your stock levels, right? The bunch of humans support that, but now with the systems, we are making things much faster because they are pretty much aggressive and fast comparatively with a human physical effort here. Now, that's where the productivity is something that we are improving overall. And healthcare, I think which I told a little yesterday as well. So in healthcare, what's happening is while we are doing the surgeries, right? So especially with the 3D vision and robotics, right? So the gestures and emotion recognitions are trying to improve the patient robot interaction, right? So based on the gesture and how patient is expressions, right? Patient expressions and emotions, or patient's gestures. So based on that, the interaction between the robot and patient are much more getting mature. And again, this is where so that's purely an automation, which is like reducing the human error, and also the for example, the recovery time as well, right? Uh, so John Hopkins, I think already there in their labs, I think they already have these sort of a surgical products. For example, the product that you are seeing is from the John Hopkins, because so they call it as the Vinci surgical systems, so right, where all these are like AI robotics tools, which primarily helps in doing the surgeries along with the surgeons. Again, autonomous vehicles and drones. I think autonomous vehicles, I think, rely on multi-sensory architectures, where you are combining the lidar cameras and also the radar for most robust environmental awareness, right? So, because when we talk about autonomous cars, they should yeah, take care of a bunch of things. They should understand how the environmental condition. They should able to act accordingly if the environment conditions, if the weather conditions change, or if the how the road situations are, how the things are, and the surroundings. So all those things really matter, so that they perform effectively. Since we are talking about autonomous vehicles and drones, I want to show you one of the examples, or one of the companies from Bhopal, which is like Madhya Pradesh, where they are trying to develop a autonomous vehicles for Indian road system. I think this is something I told yesterday, but I want to show you the realistic thing how they are making. So look at this company called for example, Swayth Robots. Okay, Swayth Robots is a company based out of Madhya Pradesh, Bhopal. It's a startup, but look at the things that they are building. What they are trying to do is they are building the autonomous robot systems. So they put the cameras of autonomous systems on the Bolero car, and they are trying to build the more five-layered of autonomous and systems in the Indian ecosystems. For example, if you look at their videos, right, see how they are trying to run on the Indian road. So look at this video. So they are making very interesting stuff, but so I've been reading them, I think from last couple of years. I think they are progressing very aggressively on the especially on the Indian road systems, how they so look at this Bolero, how effectively they are trying. It is working with the help of autonomous. So they'll use all the the convolutional neural network ecosystems under this, and making things more robust here. Uh, so if you look at their mission, also they want to build like five-level autonomous driving technology, like where vehicles can operate fully autonomously, meaning that there will be no human intervention. It's like, everything that vehicle has to perform on its own, like, so it has to stop at the signal, or if there is any hole in between, it has to cross over it without a fail, or if it is see any speed breaker, it has to stop and react it. If it is a signal, or if it is there in the environmental condition, it has to act fully on this. Right. So look at their goal. Their goal is to conduct the compelling 100 kilometers per hour autonomous driving demonstration on Indian roads. Imagine on Indian roads. For example, Indian roads, right? For example, every state has a different set of a road ecosystem. And even if you look at the villages, look at this. For example, this is purely on the village road system. So imagine if we want to develop things fully autonomously on these sort of areas. So how effectively we need to train our system, right? How effectively we need to have the diet data. Firstly, we need to have the diet data on that diverse aspect at the prom, and same time how effectively we are trying to train the system so that it will act, right? But they are really doing very interesting stuff. Just go and read whenever you get a time. But Swiat Robotics is one of the great thing, and look at their accomplishments as well. It's like the founder, and look at the ecosystem that they have been improving all the years, right? From like last 3 years, how they are making interesting. You can read more about them, but that's where we see the autonomy, especially on the vehicles, eventually in the upcoming years. Okay, let's go back to the uh, okay, right. Uh, but that's pretty much on the autonomous part. And talk about the physical AI, right? Uh, so initially, when we start about presentation, so we are moving purely from right the digital AI to physical AI, right? So physical AI is nothing but where we are trying to enable the machines to perform autonomously, understand, perceive, and also uh, uh, understand the underlying reasons about it, and also interact with the physical world in real time. That's what the Swayat robot example is all about, right? So it is basically trying to perform things autonomously, trying to perceive the environment, understanding the environment, looking at the reasons, looking at the surroundings, right? And based on that situation, they're trying to act accordingly in the real world. It's not that easy, right? In again in a traditional unlike the traditional robots, in most of the traditional more, as I mentioned, they are pretty much on the pre-programmed, right? So like they follow fixed instruction, they have a fixed rules, but physical systems are slightly different, where you need to adopt things like instantly based on the conditions. They need to perceive the environment, learn from the experiences, and also adjust the behavior accordingly. That's where the whole things are moving now. And most importantly, the real-time decision making, right? So these systems, for example, can navigate and also make unpredictable things, right? And also the complex environment. So because we might not know because we might face a lot of unpredictable things throughout the process. So we should able to make more effective decisions on the fly, like instantly throughout the process. And again, as I mentioned, autonomous deployment, again, that's where the physical AI is moving from research labs to the real world production. I think with this 2026, so we've been seeing more physical AI coming into the world from the traditional systems, and some of them are already in in real world. For example, inspecting the power grids, right? So AI powered drones and robots are already inspecting the power lines and also the substations, where it trying to identify the faults and also trying to reduce the need for dangerous manual inspections. That's where they're trying to work, and things are moving there. And as I mentioned in last session also, in agriculture also drones are trying to, do the farming in the crops, right? Farming, they're trying to, in trying to inject the crops in the fields, right? Rather than human going and putting the crops in the field, right? Drones are trying to do it already. And of course, assisting in surgery is already happening because robots are trying to assist the surgeons with a lot of precision tasks. Again, which is again making more real-time imagining and AI-driven guidance to improve the outcomes and also reduce errors. So it keeps learning from the things and also iterating and also improving eventually, through the experiences. Uh, Navigating city streets, I think Swayat Bharat is a very good example here. I think so. Autonomous vehicles and also all the delivery robots. So they navigate through the city streets or any streets, local streets, international, whatever streets we just call it. So they are trying to, for example, deliver things more efficiently, right? Or it could be either the vehicles or maybe the delivery robots, for example, where they are trying to, for example, deliver things more efficiently. Uh, Warehouses, again, robots are trying to work alongside with the humans in warehouses. For example, handling a lot of repetitive or heavy tasks, and this is where they are trying to increase overall productivity, right? Because as you see in the warehouse system, where we have smart robots which are trying to move the goods, right? Instead of humans lifting all those things, so robots are coming and they are trying to move because warehouses are so big. So it's very difficult for a human to move from this side to that side, right? So that's where the things are coming up. Uh, okay. Yeah, of course, the future will be humanoid robots and physical AI. Again, if you look at all these are like different robots where companies and also the research they are trying to implement it. So they are moving from the experimentation phase to the real phase, and again, all these the sort of robots and also the applications will impact the industries. From if you take anything from manufacturing, logistics to healthcare, or even agriculture, right? So again, Tesla also has Optimus robot, and SoftBank Pepper are advancing this real world humanoid application. So we'll see more humanoid applications eventually over the years now. And uh, so so, so the objective of a humanoid robots are basically is to again to navigate the environments, and again these are built for humans, not to replace humans. Most importantly, this is something we should always remember, right? So we all, now we might be in a confusion state again that because when physical AI and humanoid robots are coming in place. So what happens to the humans, or do the humans exist, or do robotics takes everything from humans? It will not like that. the reason behind for having this humanoid robots to speed up things. Again, all these things are built for humans, not to replace humans, because the human, as I mentioned, the human and AI collaboration is equally important. Otherwise, we will not able to achieve or build these things more interesting. So end of the day, all these applications is to speed up things, like improve things where a lot of repetitions are happening or a lot of manual effort is required. Right. This is something we should always remember. So all these things can operate in existing infrastructure without costly modifications. So some of the projections, the numbers from some of the research reports, it says that so we'll be seeing the 2 million humanoid robots in use by 2035, and again by 2050 it could be like 300 million in the market size, with like close to 1.47 to 1.17 trillions by 2050. So the market size opportunity is going to increase like that by the 2050 and all. So as I mentioned, a lot of companies of different industries, including research, are actively investing in this and actively working on this things. Again, finally, just want to say that so AI and robotics, all this will not replace humans, but people who are not leveraging these things, but they might replace. And people who are not leveraging AI, then those people will be replaced by AI. But AI will not replace humans. But AI will help us to simplify things, improve things. But if we want to be in the race, we have to, leverage it. We have to upskill it. Otherwise, it will be very challenging down the line in the future. Uh, Again, so again, building these applications in real time or building these autonomous systems is not at all an easy thing. Right? Might face, not only we may face a lot of challenges throughout this process, and we've been facing it already. It's not something coming up new. It's been already happening. But over the period, what happened so far is, I think things, systems, models, technology got more matured comparatively with how it was earlier, right? Especially on the simulation to real gap, of course. So robots or automation system often learn in simulation, but real world environments are really unpredictable, right? So there is no predefined structure or a phase where you predict the real world environment every day. So you cannot predict every situation of a real world environment. There could be a lot of different things that comes up, but we should be in our systems should be in such a position that they should adopt things. They should understand those things from the experience, and they should adapt, and they should uh, perform more effectively. That's the whole goal that we are trying to solve. Again, safety and trust, which is really important, because when we build about humanoid robots or physical AI systems, again, there is high possibility that they can make errors, they can cause a lot of damage, they can right, they can do any sort of a mistakes. So in order to overcome this, I think that's where the human oversight remains critical. So human intervention is really important. Again, I strongly believe that again, without human intelligence, there is no artificial intelligence existing, because artificial intelligence is not something it got created by its own. It is something that has been developed or created by human itself, right? So the human oversight always remains very important here. And most importantly, the data management. So we've been collecting a lot of data. So when we have to build these sort of a physical AI applications or humanoid robots, we need a massive amount of data. Like we need massive sensor data, like 3D models, digital twins, all of data from the internet. So it requires very diverse data. So that again, so the data management is also very crucial in order to build these effective applications. Regulatory gaps, of course, this is also important. So we need to stick to the regulations when we are building these sort of applications, because every country has a different set of regulations, rules based on the ecosystem that we have. Because India might have a different regulation and rules, where it is different for Europe or Middle East countries. So it's really important that we should equally keep the regulation guidelines in place, the governance guidelines in place, so that we build a safe and secured standards of applications that will not, that will help us in real time rather than damaging entirely, right? Agentic AI convergence, of course, agentic AI is more getting matured year by year. From 24, it was very nothing. I mean, it's all agents. Now 24, it got agentic AI systems. Now agentic AI systems is getting more into the convergence from 2026, right? So when you merge agentic AI with a physical AI robot, so which helps the robots to fully perform autonomously on a multi-step task, and they can adopt to the all the new things or new environments and recover from their failures. If they have met any failure, they try to recover and understand from the failures and operate more effectively, and also even under uncertainty conditions with human in the loop oversight. Because as I mentioned, human in the loop, or now people are talking about human in the loop, it's more about human on the loop now. So there's a difference between human in the loop and human on the loop. That's where we're going to see. And and a lot of again industries also talks about, for example, we saw in healthcare, it's already helping all this with the help of a surgical robots. And a lot of industry reports and also the organizations say that now for going forward, the enterprises will embed this task-specific AI agents applications, right? For example, if there is any underlying task, let's talk about, for example, if it is a more on surgery, right? So they try to build some sort of a such task-specific AI agent applications that can perform the task fully autonomously with less human intervention. So this is where the primary focus is going on, and especially again, it could be any industries because AI agents are coming in everywhere, not only for either healthcare, marketing, or warehouse. It is there in finance. It is there coming in supply chain. It's coming in SAP. You just name it. I think it's just they are trying to jump in every industry. Right. Uh, Implementation strategy again. So in order to implement these cutting edge technologies or the use cases, first is identifying the use case is really important, because until and unless you don't have a proper use case, there is no point of doing this. So, for example, these days, what happens is people are just chasing it, especially on the enterprise level, because everybody is building the agentic applications. I should also do something out of it, because that's where people are burning money, people are burning resources, but end of the day, you're not getting any sort of ROI. So firstly, identifying use cases is really important, and start with small experimentation. Like for example, small experimentation, again, look at for a high ROI, low risk application. So low risk applications are nothing but you should start with a small thing, and you see how effectively you are able to get it. So if it is really good, like you're able to achieve good things out of your experimentation one, then you can scale it up. Scaling is not a problem, but identifying a real use case and targeting for the higher way is really important. Otherwise, it doesn't make any sense. You're just otherwise, what happens is worst case you'll just burn money, or you'll just face the resources. I think that's where Salesforce has failed. So as I told you yesterday, also Salesforce has removed most of the employees, and they have relied heavily on AI, and that's where they got into the losses. Right? It will not work like that. And data infrastructure, of course, it's really important. So you should have the systematic data collection, labeling, because all these are essential, especially if you're building, these cutting edge applications, right? And next, you have to choose your tech stack wisely. Again, it's good to follow most of the industry standard tech stack, right? For example, a lot of open source ecosystem has been in rise because people are trying to adopt the open source technology rather than going for a proprietary software or proprietary software or proprietary tools, because most of them are all easily accessible in open source, so you can just quickly leverage and see again. So you need to be very choosy in terms of selecting tech also. Again, this is where it comes the talent expertise, because you cannot go and pick up a very huge models for doing a simple summarization task or simple task. Right, for simple task, you don't need to have a 100 billion parameters model. You don't need that, right? Or else 100 million parameters of a vision model, or fully advanced vision model to solve it. So it all depends upon the use case and what kind of a problem you are to solve. Accordingly, you need to tweak your tech stack and uh, play around with it. Yeah, talent again, and some talent is really important. Again, talent is always a challenging because the technology is vastly improving day by day. Finding a realistic talent is challenging, but this is kind of a journey. So we should keep upskilling ourselves based on the experiences and the things that we do. So, of course, so in order to build, for example, the effective humanoid robots or physical systems, you need to have a very good engineers, of course, domain experts, and also safety specialists. The reason safety specialists is because they have a good understanding about the regulations. They have a good understanding about the governance standards, legals. All these things are really important. Again, continuous learning, because all this feedback loops and model training with real world data, right, which helps us to improve things and make our application much better. Safety and ethics finally, because bias plays a very key role, right? So we should thoroughly conduct the bias test and all, and also if we are building the humanoid robots or physical AI, you should have the safety certifications and human oversight protocols. So, it's a very it looks very easy while reading it, but in reality these are very very big challenging and big processes. Then only I think the whole application or a whole output or a whole system comes into the picture. Let's say you build some humanoid robot, so that should be completely tested with bias, because it cannot go and talk something on the bias side. Right, or and it should also have the proper safety certifications, proper guidelines, so that is something that it is helping to the real world rather than it is threatening, right? Uh, these are the whole key takeaways of the session. So we understood that the shift is happening from digital to physical AI, right? We'll be seeing more physical AI over the period, and the humanoid era is already, coming into the place. And some of the industry report says that we'll see the 2 million humanoids by 2035, and 2050 it could be increase more market opportunities and all. And for educators' perspective, I think now you should teach the AI and robotics more in curriculum, including how it has to be integrated, what kind of a software, what kind of a technology we can leverage through the industry standards. And the best part is, I think most of them are open source and freely available. And even for educators, I think there are some decent amount of credits that all these softwares will give, I think that makes you, I think, much better in terms of teaching the AI and robotics to the upcoming generation in a much efficient way. From practitioner's perspective, I think follow the technologies or the tools again as per the industry standards. I think, but in terms of experimentation, I think there, as I mentioned, the open source tools. We have a lot of open source tools and technologies that are available for us. So start with a small experiment and see how it's performing, how it is coming up, and then eventually scale it up effectively. So it's like an iterative journey. It's not something like, we have a start and stop process here. It's like, complete whole iterative life cycle throughout the journey. Uh, yeah, so these are, I think, some of the references that I have for the sessions. With this, I think I'll take a pause. If you have any questions, I'll be happy to answer.
Kalyan sir, thank you so much. Sir, I have one question, personal question.
Okay.
Sir, I want to know where exactly the India stands in terms of AI. That is, so is there any companies are trying to build humanoids
Of
such?
Yeah, so humanoids in India, that's where I think, for example, if you see, these are we are here. For example, so there are some companies here. For example, the Boston Dynamics. I mean, these are some of the companies which are actually doing. But Indian standpoint, I think we are not like that majorly advanced. But in terms of AI, we are really good. We are building the India first language model, vision models. For there is a company I think called Sarvam AI. Let me quickly go and show you on my browser where it is. Okay, I'll show you. So this is one of the companies, India's work company, which has also Sarvam AI. So they are the first. They are trying to build the first Indian language models. Okay, and they do a bunch of interesting stuff. Just go and check their website, what they are doing out of it. Uh, so again, in terms of humanoid robots, I think they come eventually. They are already in the active phase, but eventually it will be in place. So that's what I think. I was talking about. Right? By 2035, we'll be seeing most of them in action. Uh, yeah.
Sir, I have one more last question. That
Uh,
is, actually, students are frequently asking us, so if we work on deep learning and projects on artificial intelligence, what about the job opportunity? So, is there any company, exist in Bangalore, Hyderabad, there, where they can recruit students in this stream, that is in AI stream? So,
Yeah, yeah. I mean, there are a lot of companies where opportunity for students, but again, it all depends upon so learning deep learning or learning AI is not a problem. The problem is all about what kind of a projects that you have on your resume. Right. So if it is like, simple data set, you're just pulling it from typical. A lot of resumes I've seen is like, people take the simple data sets from Kaggle, like for example, Titanic data sets or credit card data sets or product. So it will not work like that. So these days now, the people, what they see on resumes is like, how effectively you have built the whole project, right? The end-to-end ecosystem in the sense, like, what is the problem that you have solved? Okay, let me put it in a very clear way. Like, what was your problem and how did you approach in solving it and what was the output? Right, so the whole architecture, and if you are able to build on these things with a realistic applications, right? I think that's where you stand out rather than doing like typical traditional projects. So typical traditional project doesn't have value if you have built like entire the niche systems. I think that's where you mostly stand out from a student perspective. So certifications are again people say that I have a certification and all. Again, that is partially valid, but we like do not completely rely or take people on based on the certifications. It's all about how much practical exposure or practical experience that they have built. So we primarily look at their code. We primarily look at how did they build the architecture out of it. So all those things are really important, especially if you want to hire students. And again, there's also opportunity that some companies even hire as interns. They just want to solve problems. So look at a lot of, for example, the open source AI companies or open source software where they help a lot of students in terms of getting interns in solving some problems. So that's where I think they get more, the hands-on exposure. But in order to get that, I think you should be something. You should build something realistically with experience rather than just learning the typical course.
Yes, sir. That is building realistic projects is very important.
Yeah.
Yes,
So
sir.
again, in order to build also, let's say you do not have idea also, you can just talk to, for example, AI tools to get some ideas. Because all these, so I always think that you should always treat the AI tools as your companion or like maybe your best assistant. So they will help you in much more things. Let's say you don't know anything, you can just go and talk to any of the AI tools. Just say that, I'm a student. And for example, this is again just a random saying. The example I'm saying, let's say I'm a final year student and I want to crack some internship or opportunity. These are my skill set. I want to build one interesting, realistic project. Give me some interesting idea that will not be repetitive or something like that, where I can stand out in interviews. So if you are trying to ask these sort of questions to AI, that will guide you much better. It will give you
Obvious,
very realistic ideas. So just go and
obviously.
build. Take the idea and just build out of it.
Yes,
Right.
sir. Yes, sir. Yes, sir.
Yeah.
Obviously.
Yeah, I mean that's what we always do. Even so, I do on a base-to basis. So I use all the AI tools on a day-to-day basis and for various tasks and various things. I keep talking it, so there's no wrong it at all. Wrong at all. Even in interviews also, there are some companies which are giving AI tools to solve your the coding problems. But primarily, what I say is because these days, especially the students, they are pretty much attracted towards the buzzwords, what is floating in the market. Because now people talk about agentic AI, people talk about generative AI and all, but people ignore the foundations. Let's say people don't know basic SQL sets. Right, so they don't know how to retrieve the data, but they want to build agentic AI applications. That's where they fail. So I always personally, recommend or guide people, especially students, to focus first on the fundamentals. So if your fundamentals are really good, you can learn this advanced technology. So it's not a problem, I think. But without fundamentals, it's challenging.
Yes, sir. Yes, sir. Actually, as a faculty, we tell all these things. Students will not listen. Yeah, definitely, I'm going to show this video to, display. That is this video to students. Actually, the person from industry, if they tell something on this, definitely they are going to listen. But if we tell, that is as a faculty, if we tell all these things, they are going to ignore it. That's why I asked this question, sir.
Yeah, yeah, understood. I understood. I mean, that's how it is. I mean, people who understand, I think they'll do it. People who don't understand, they'll realize when when they come into the situation, when
Okay,
they
sir.
encounter that situation. Yeah.
Thank you so much, sir. Thank you so much for your precious time, sir.
Thanks, Mahesh, for having me. I hope you all enjoyed the sessions. Yeah.
Uh, Dear participants, no, sir has given actually spread light on AI applications in a different paradigm and continued the previous session. So I hope you get benefit from this. Kalyan, sir, thank you so much, sir. Thank you. Dear participants, our next session starts from 3:20. So I request you people to stay online till 3:20. Pawan sir, Pawan sir, Pawan sir, Pawan sir, am I audible? Okay, sir. Okay. Pawan sir, Pawan sir, you can unmute now. Pawan sir, Pawan sir,
Hello.
Pawan sir, it is now audible.
Yeah, yeah. Sorry for the inconvenience.
No issue, sir. No worries, sir. Uh, Pawan sir, thank you for this session, to come to this session. I welcome you to the session, sir. It is already late. I think you can engage the participants now.
Yeah. Thank you, Mahesh again for the opportunity. And I was here yesterday, uh, day before yesterday, talking about ethics and sustainability in AI. And today we'll be covering a very interesting topic. In fact, I should not call it a topic. It's something that it's now embedded in all our lives. Uh, so before we begin, I have two things to say. So one is I'm traveling and I'm little outside, so there could be a little noise and disturbance, though I'm trying to keep it as as less noisy as possible. Second is my PPT kind of just failed today, like it's cherry on the cake. So I had to convert my deck into a PDF and I'll be presenting the same. So please, the listeners, please don't mind. It could be a little boring, but I'll make sure I'll keep it very interactive. Visuals can be a little black and white, but I'll try to keep it very interactive and everything. So let me quickly share my screen. Yeah, is my screen up?
Yes, sir. It is visible, but you have to enlarge it. That's it.
Yeah, I'll do. Is it up?
Little
Better?
bit more. Little bit more, sir.
Better?
Okay. Okay. Quite good, sir. Quite good.
Okay. Okay. So I'll hide the thumbnail video so that you can see. So before we start, okay. So a very good afternoon to one and all present here. Sorry for the little inconvenience that happened, and let's begin. Okay. So every day when we look at our phones, we have a very good feature called as face unlock. Have you ever wondered how this works? Like, even if it's a face that's clean shaved, even if it's a face that is with beard, or even if it's a face with or without spectacles, everything works and your face is recognized properly. And if anyone tries to interlude, it doesn't unlock. So, deep learning, today's topic, is like electricity. It's present everywhere. We are using it on a daily basis, but it is in the background. And we are not actually seeing how it works, but it is embedded in every small little things of our life. Going forward, we'll understand what exactly deep learning is and how humans have created one entire framework that can actually uh, help, or that has actually helped us create so robust systems that we actually just have to. So we use our face as boarding pass in DJ Yatra. That's how better, or that's how evolved deep learning has become. So I'll I have split this into four parts where we'll see how the deep learning evolved, and then what are the different kind of architectures, and some deep dive into architectures. There is a lot of math. We'll not go into math because it's a lot of statistics and computations, but we'll understand them. Then challenges and futures, and then I'll discuss some of the real life use cases. And there is a code that thought I would give a live demo, but probably now I can't. And we'll have a small Q&A just to understand how much of the topic is picked up by the listeners today. And if you feel that anywhere you want to ask something, please feel free to interrupt me before I walk further. So, what is deep learning? This question actually doesn't have a very exact answer. If you see, traditionally machine learning had very limited boundaries, like especially when we look at the predictive approaches, machine learning uh, could go only to an extent using the formulas. But the human intuition or the human touch was missing in machine learning. So, in around 1980s, people much before that, in fact, I think in one of the articles I was reading somewhere that deep learning dates back to Gulliver Travels days, and there were people who were using some kind of um, pattern detection methods to actually understand a few things. But coming back to our topic, so deep learning is let me put it in layman terms. When some non-tech person comes and asks me, "Hey, what is deep learning, or what is that you know GPT is trying to do?" So I just say that imagine a group of people try to recreate how our brain works, though it's literally not possible to completely recreate the brain, but this was an effort, and this effort proved to be very successful. So deep learning refers, so when we talk about brain has neurons. Neurons send messages to each, pass messages through each other, and that message reaches the final stage wherever it has to reach. For example, when you touch something that's very hot, a neuron in your brain sends a rapid response to your hand that you have to take that hand out, otherwise it will burn. So that's how fast, efficient our brain is. And researchers said, let's recreate it. So the neural networks are nothing but these are uh, deep learning is nothing but these are a set of neural networks with multiple hidden layers. When I say hidden layers, these are basically those neurons that are carrying the message to the final node. And what what this does is this helps them analyze complex patterns that is present in the data. Now, I said deep learning was there in around 1980s, then why it didn't come to picture? Because we had limitations. We had limitations of the data, we had limitations of the GPUs that were present. Now, since we have evolved, to on power, compute, and the amount of data we have, that is why deep learning has become so significant. So, like I was talking, it's the biological inspiration that it is there, that from a brain cell to a math to a statistics, that kind of works. So if you see in a biological neuron, there are dendrites that receive the signal, cell body that processes the signal, and axon transmit the signals to other neurons. So it is very loosely inspired, but that is the reason you don't have general GAI in place yet. The general artificial intelligence is not in place yet because you cannot completely mimic the brain. So the perceptron, it's a single layer perceptron that was initially proposed. What happens is we have a set. We have how deep learning works is it takes the input, and each input is given a certain set of weight, and each weight is then passed on, calculated, and then there is a function that works on it we'll study more on the activation functions going forward. So what it does is that function kind of removes whatever unnecessary part of the data is, and then it tries to study what is the necessity part of the data and how it is related to the input, and then gives you an output y. So the initial perceptron, it was a single layer perceptron, and it could do only binary classification and or not. It couldn't do any kind of non-linear classifications, and that led to the development of multiple layer perceptrons. So what is this multiple layer perceptron? There they started adding hidden layers. Now what these layers do is they try to filter out the noise in the data. Let's understand everything of this in a very layman term. It's more like there is a Chinese game that's called as passing the message, but in that you have to keep the message intact. Here, each layer only filters what is needed from the input, and as we add more and more layers, it kind of filters or secretes the information that is needed for the output, and then it tries to generate or predict the output based on this. Now, hidden layers can, begin from 2 till n. N can be any thousands of layers. We have models that are built on thousands of layers of hidden layers. But again, when we think, in a broader perspective, how many layers do we actually need? It all depends on the use case. And going further, we'll understand why the layering system is very, very important when we talk about deep learning. So, multi-layer perceptron, like I said, it can learn any continuous function. It will learn the linearity in the data, and it will also learn the non-linear relationships that is present in the data. Now, since we have huge amount of data, there are n number of patterns. So for example, if we take a data of sales for an umbrella company, we see that there are different type of patterns for different type of regions in different type of weather. So monsoon is across, could be across all the regions, but in summer also some regions would have different set of patterns. So to study all these linear and non-linear relationships and to establish a connect between them is why we need a MLP. So every neuron is connected to the next neuron. So like I said, these messages are being passed, and whenever we are passing these messages, we are passing information, and each information is processed so that the output can be predicted more closely or more accurately. So activation functions. So this is what I was saying from slide 3, that what is activation functions? So adding non-linearity. If you don't add non-linearity, there are non-linear patterns that are present in the data that the system won't pick up. So it will generalize everything using one pattern, and that kind of becomes a bias. So non-linearity is important to enable complex pattern learning. That's what I said. So you don't want your model to learn only one single thing. There could be n number of things, and each of them has to be picked up by the model to understand. And for the people who attended the session day before yesterday on ethics, we were talking about example of bank loan. So people who are getting approved on bank loan also will have a number of patterns. It could be a combination of own house, own vehicle, and something else. And then there are a group of people who don't have own house, but they have own vehicle. So n number of patterns. If you don't have an activation function, it will just learn it in a very regressive way, the linear regression, in a regressive way. So it would just learn that any person who is having a higher income is eligible to get a loan, which is not a real world scenario. And that is the reason you need activation functions. Now there are different type of activation functions that are present, and the most common ones are sigmoid, where your output is so basically activation functions, the only um thing that they do is introducing non-linearity into your networks. So tan h, and if you see on the right hand side, I have given the ranges from where those values are. So sigmoid is from 0 to 1, tan h ranges between -1 to 1, ReLU is 0 to infinity, leaky ReLU is minus infinity to infinity, and softmax is 0 to 1. So there is one more very important thing here we should learn, that that is present in most of the neural networks today, the vanishing gradient problem. So what is a vanishing gradient problem? It is um, a issue where error signals become extremely small as they propagate uh, through many layers during training. So what happens is this causes uh, the weights that are getting updated for each in each layer will becomes very slow, and the network's ability to learn complex pattern diminishes. So to avoid vanishing gradient problem, ReLU and leaky ReLU is something which is used frequently, but there are something like residual connections, Xavier he initializations, batch normalization that is done. So vanishing gradient problem, in a if I have to put it in a very layman simple term, is if while your network is learning and the propagation has become too many layers has become very slow, so the weights start updating very slowly, so your network doesn't learn the patterns very correctly, complex patterns, right? So let's understand the how data flows in the network. There are different types of propagation flows that are in a neural network present. So the first one is the forward propagation. So very simple, as the name says, the data is sent forward and forward into the network. So you have an input layer, and then you have the layer 1, layer 2, and the n number of hidden layers that you have decided to add, and then you have the output layer. So no data is coming back. Everywhere the data is being passed onto the forward set of neurons. What it does is each layer it does a linear transformation, and then it does a non-linear activation as well. So both of these are important to understand the linear patterns in the data and to analyze the complex pattern. So always think in this way, that you have a network that has an input layer and output layer, and in middle there are hidden layers. Now there are two things that each neural network will do is understanding the linearity of the data, but that will lead to only very restricted set of patterns. But to understand complex patterns, you need a activation function that helps you understand what kind of different patterns are there and the correlation between them, right? So now neural networks, like I said, work in the direction of flow is um, there are different types of direction of flow. The first one is forward propagation from input to layers to output. So what happens inside, like I said, we'll not get into the details of the math, but it is a set of matrix multiplications that is happening. So in corporate industry, whenever they say that there is a very joke that people keep saying that at the end of the day it's a matrix multiplication happening to with a kernel value, but it is not that easy because you're scaling it to a different level, and there are so many noises that are included that you can't do it actually manually or even with your codes. So that is why you need neural networks. Then loss functions. Um, Loss functions are basically just to understand what is okay. Before going to loss functions, I'll talk about backpropagation here in neural network. So backpropagation is a supervised learning method. In the slides, we will see that. So uh, the whole point here is to minimize the loss function. So let me talk about loss function first, and then we'll go to backpropagation. So loss function is nothing but how do we measure? So in predictive models, we use uh, F1 score, we use the precision and accuracy, we use the recall or sensitivity of the model to see how our models are predicting. But since here we are dealing with a set of neurons, and each neuron has had some loss of information, we have to see how much information is lost in complete set from input to output. So loss functions becomes very important there. So classification loss, whenever we are using a neural network to predict categories or classify, for example, classifying an image as cat or dog, or predicting whether this review will be uh, flagged or not, there we use the cross entropy loss. And for regression, we use the mean squared error loss. So both of these are very essential as these determine how well your model is performing. And by that, I mean how much information, how minimal information has your model lost during the transmission of data. So from input to hidden layers to output, how much information has it lost? So lesser the loss, better the prediction because the information is intact, right? So for multi-class and binary, we have different type of cross entropy. So lower loss means better prediction. So this is what I was saying. If your loss is less, it means the information that the network has learned is very well, so predictions are better. Yeah, so I'll talk about back propagation now. So we have understood loss function now. Now your loss, for example, you trained a model and you see that your loss, the information that you're passing to the set of neurons is pretty high. Now you want to reduce the loss. The primary goal here for back propagation is to reduce the loss. How it does is it the information is sent back to the network. So this is where the direction is changing. The iteratively the neural network starts sending back the information, adjusting the weights and biases. And this is how the model gets better. So if you see the core algorithms is 4 step. So it does a forward pass and computes the prediction. Then it computes what is the loss. So if the loss is very high, it does a backward pass. When it does a backward pass, it iteratively adjusts the weight and everything, and then feeds it back to the network again. So backpropagation becomes a very important supervised learning method to train these neural networks. And you will see that in most of the cases where your loss is very high, where you're losing out information in neuron, backpropagation is used. So here there is one more advantage, that the backpropagation computes gradients more efficiently than the basic methods. So when you're passing the information to forward networks, there the computation might be a little not so strict, but when you do a back propagation, that is when it gets more stricter because now it knows that the loss function is very high. So there are two limitations for back propagations. One is data dependency. So it has to be very good quality data. If you do it on a noisy data, it will still be not that efficient. Second is training time. So if you are handling like GBs of data, your back propagation will run very, very slow. And the vanishing gradient problem, like I said, that because the weight computation becomes slow, the information again uh, keeps losing and your loss functions keep increasing. But the whole point of back propagation is something like, hey, I'm sending you back the data. Can you please adjust the weights and send it back? And then you get the adjusted weights and then you don't lose that much of information, right? So there are different optimization algorithms that are present for now. Like I said, deep learning, the neural networks are very, very complex, and the results cannot be in line with whatever we are trying to actually predict in most of the cases. So there are different optimization algorithms. So it is the in one way, if we have to understand, it is just finding an objective function, whatever the objective function we have defined, and making sure the values are predicted very closely to that. So there are gradient based functions, and then there are second order algorithms that are present. Then there are derivative free algorithms are present. So if you see SGD, Adam optimizer is something that you will see being used most in most cases. If any one of you have trained any BERT models, there you would have used Adam only. So and then you have ADA grade and all. Like I said, there are um, second order based algorithms like Hessian matrix and Newton's method, quasi-Newton method like BFGS, all these are present. But the most popular one is Adam's algorithm. So the whole point here of using an optimization algorithm is making learning efficient so that each prediction is very close to actual, right? So the key hyperparameter that you adjust here is the learning rate also. Learning rate usually, in basic, if you are doing a model building or any code you take out from internet, it is 1 e to the power minus 5. But it is not always a standard one. When you adjust learning rate, it is you're telling how does the model learn these patterns. If you keep it too small, the convergence will be very slow. If you keep it too large, the divergence or the complexity of patterns or oscillations will be very high. And how do you find the just right algorithm, just right running rate is? It's a trial and error. The grid search kind of helps, but learning rate is one key parameter that helps you understand how much in what rate is your network learning and how will be the patterns. And basically, what this when we say when the network is learning, what it does is it's the step size during model training that it controls, that it knows how much weights have to be adjusted. So when you keep the right learning rate, size is perfect, and that step size, because that is perfect, the weights that are calculated will be also proper instead of doing back propagation. If your learning rates are quick, better, your networks also will be better. So a quick check. So why do we, that's what I was saying right in the beginning. Why do we need multiple layers in a neural network? Because think about it, a single neuron can only draw a straight line. If we are talking about all the new technologies that have come, and like most of us have used Chat GPT to generate Ghibli images. Imagine the number of neurons involved in generating an exact cartoon replica of your photos. So This is why we need neural networks, that every neuron does some kind of function and brings some kind of information to the table. And at the output layer, we have a collection of information that is blended as an output. So let's understand the different architectures that are present. Architectures of deep learning are based on the problem that you're trying to solve. So here is a quick table for a quick understanding. If you're dealing with images, that is detection of something in the image and classification, convolution neural networks are your answer. And we will talk about each of these architecture in a quick glance to understand what each of these does. And then if you are talking somewhere in time series sequence of text, prediction and translation, you are using RNN or transformer. So transformers are a cutting edge technology that is being used in GPT. We'll talk about that also. Complex patterns, generation and encoding GAN and autoencoder, and multimodal, it will all of them are transformer based only. So multimodal includes your chat GPT 5.0, 5.2, that is latest, that is present, right? So let's talk about each architecture quickly to understand what actually happens in each of them. So CNN are basically designed for images. So each image is made of pixels, right? And each pixel contains some kind of information. So for example, there is an image of a cat and the background is just a garden. Now the whole point is we want our network to focus just on the cat and not on the garden. So each pixel carries some kind of image information. What CNN actually does is it extracts all the features from the pixels. And there are two key operations that it does. One is convolution, hence the name, and then pooling. So first it extracts all the uh, features that are present in the pixel, and then it pools. That is reduction, reduces the dimensionality. Now you don't want the whole features to know whether it's a cat. You just want to know, you want that specific cat's information to understand it's a cat or a dog, right? So okay, I have put a quick architecture here. So what it does is there is an input image, and if you see A to L is something like a pixel. Each is representing a pixel. And then you have a filter kernel that is telling where is the information that is to be present. Now there is a filter or kernel multiplication that happens and it creates a feature map. Now it is being done on every layer and every layer is passing some kind of information. So if you see, filter type is detection of edge, or if there is any kind of blur or pattern, blur that is present in the image, or if there is any kind of texture that is present in the image. So a convolution network, CNN does two things, convolution and pooling. So extract the feature and reduce the dimensionality and create a pooling so that you have only the features that you require to look at. So I have added slides of the mathematics of pooling and spatial dimension. So if you see here, how max pooling works here is you had an input matrix which was 4 cross 3, and now with dimensionality reduction we have come to 2 cross 2 matrix, because this reduces the computation, and this is the only set of features that you need to for the network to understand what is present in the image. So if you see the complete CNN architecture, it's the input image, that is, and usually images are all in RGB uh, and color pattern, but sometimes we convert it to black and white also to make the model understand better, but you can use color images as well. And then we have convolution plus ReLU activation, then pooling plus ReLU activation, again we convolution, and then fully connected neurons we have that creates a output of the image or predicts. So CNN architectures evolved through a lot of things. I'm sure most of us in college, for us, the first CNN was handwriting recognition. Like if you could write eight in three different ways, and if your system was able to recognize, it was a huge hit for us. So it was a simple 5 layer architecture, and then ImageNet is one algorithm that came and that did a breakthrough. It was able to classify dogs and cats. I think that was the first thing that they had done. And then we had VGGNet, ResNet coming through. So this is all the history of CNNs, but the handwriting recognition one is still the classic. I mean, if I think most of you can ask the students to go back and let them understand this handwriting recognition using this CNN, because it is a very interesting case. You can write 8 as B, you can write 8 in as infinity, but still it was able to successfully recognize those things. Again, like I said, the residual block is where you solve the vanishing gradient problem. That is the loss of information because the weights are not being assigned properly. So real world applications, if you see, CNN excels in image classification, Instagram, everything is completely CNN. Object detection, autonomous vehicles, we were talking about this in the last session as well. Google uses it to understand what is there ahead of you. And in surveillance, I'm sure most of you have got traffic challans thanks to CNN. And face recognition. This is what we began with. Your mobile phones unlocking, just with one look, even if you are not the same when you were registering it for the unlock. Medical imaging, X-ray, MRI analysis, and quality control. Every industry that is manufacturing are using some kind of ML techniques to make sure their operations are not interrupted. They are using predictive models also to predict when there will be a problem. But since we are on deep learning, they are using CNNs to predict where is the defect. So notable examples, like I said, Tesla autopilot, cancer detection, and agriculture is one field where I'm sure there is something a corporation called as Kheti Buddy. They are using image soil detection, and they are using crop you know pest detection. Using all of these algorithms are being done by deep learning. So again, a quick um, you know uh, enabler. Just understand how, if you're building a quality control system for a smartphone factory, probably for an Apple, what are the architecture would you choose, and what kind of defects would you want to detect? Like, would you want to detect a closed USB port? So this is just for its thinking and analyzing. You can use it as task for the students so that they come up with a business use case. So CNN done RNN. So RNN is designed for sequences. So when we say sequential data, the order matters because you have written something that makes sense when you read it from left to right. Context is important, and the input or output length varies. So for example, you can give the input as a one paragraph text and you want output whether this is this or not. So that is where RNN comes into picture. So hidden state basically carries information from past. Here, the weights don't change at each step. Same weights are applied, and outputs are dependent on previous computation. Like I said, outputs can vary. If you can give a paragraph and ask whether this paragraph is, um, you can give a movie review and ask whether this sentiment is happy or not. So something like that. So input and output length varies. So if you see the architecture here, it's this is an unrolled view, but basically every layer has same weights, and information is being passed, and then you have output, and output length varies. Applications, we spoke about speech recognition, or probably it could be time series as well. Just excuse me one second. So the mathematics, the sequences is are processed using a forward pass. So whatever information is being carried from the previous neuron to the next neuron, they are applied with the same weight. Now the challenge is everywhere you will see vanishing gradients as a challenge, because these and exploding gradients. When I say exploding gradients, they are so large that the information is completely lost. And because since it is doing sequential computation, the training time is very high. So here there was one more problem that was happening, and we'll understand why it led to the creation of transformers. So if you're doing long sequences, the earlier inputs get washed. I mean, the context is not held. The memory here is very short. And information that has started from the first layer probably doesn't reach the 100th layer. Now, the 100th layer has only half information of what is being processed, and hence it will increase your loss function. So, because we had a short-term memory problem, we came up with a long short-term memory algorithm. Now, what it was doing is, because the dependency was very long, the LSTM came as an algorithm that basically stands for long short-term memory. But again, this is a short-term memory only, but only for a longer duration. So if you see here, the forget gate, the input gate, and the output gate. So the dependency of the longevity of the information that is to be passed is being taken care here. So there are three gates here. Let's understand each of these gates. So LSTM has the forget gate decides what information has to be thrown away from the cell state, like what information has to be kept. Second, input gate decides what information is to be stored in that cell states. And so because the forget gate had given it a very precise information, and again, this you have what information we have to store. And based on these two inputs, it decides what to output based on the cell state. So every gate is giving you a very precise set of information, and it is also giving you a chance to actually keep that information going for a very long duration, right? So the LSTM architecture, I'll not get into the complete architecture, but this is a what we call as GRU, the gated recurrent unit. So it has three components. GRU has only two components. So the hidden state is combined here in GRU, and LSTM has separate cell state for each of that. The GRU has less parameters and it is faster to train because you're hiding your states are hidden, there are no separate state, and parameters are less, right? So the applications again here is machine translation. I'm sure most of us have used Google Translate, and text generation, Chat GPT completely is a transformer based model. We'll study about transformers in the next slides. And then sentiment analysis. So this is what I was talking. You give a set of comments and say what is the sentiment. It says that hey, the sentiment is positive for this movie. And then named entity recognition. You give so all these time series stock price prediction. I think there is no perfect model in this world that can predict the Indian stock market given the haywire it is happening. And weather forecasting, speech to text to speech analysis, everything is being taken care by RNNs. So The sequence prediction challenge. So if you see here, the cat sat on the, and you have options as mat, car, and flying. What the model has learned is the cat is likely to sit on a mat because it's a grammar pattern. But context also matters. The dog chased might be the cat also. So capturing the cat as a context becomes important here. So for example, the dog was walking on the street. It also was eating dog food. So it here refers to dog is what this model has to understand. And when you are doing this, and when there is a long sequence of sentences that is referring to the dog as 888, the information might be lost. And that is when the transformer revolution came, because context capturing was not happening. So I'll give you one more example. I sat by the bank and then I went to the bank to withdraw money. Now I have used bank as a word in the same sentence, but each of these bank mean different things. I sat by the bank is river bank, and when I say the second bank, it is referring to the bank that deals that's as a financial institution. This context capturing becomes very important, and that is where in 2017 came a paper called as Attention is All You Need, and that changed the whole scenario, and that is what we see as a tech advancement today in the form of GPT. So Google came up with this paper called as Attention is All You Need, where attention became the word that changed everything. So it kind of abandoned the recurrence to understand the context. It said, no, I'll just give attention to what's important, or I'll highlight what's important. So self-attention mechanism, and that is why how they have come up with a transformer architecture, and all the sequences are processed parallelly, and hence you have a better long range dependencies. So now there is no problem of short term memory. All the things are captured, and transformers changed everything for us. So if you see transformer basic architecture, it's input embeddings, and then we have an encoder and decoder. Now, what attention does is attention focuses on only what is important in the whole scenario. Like I said, the it in that sentence or the bank in that sentence referring to a bank to withdraw money. Now, to withdraw money becomes something it gives attention to and says, hey, this bank is the financial institution bank. And I sat by the bank. Oh, he's sat. So that context understanding becomes better when you are doing long range dependencies and parallel processing and the self attention mechanism. So I'm so sorry I had to show this in a PPT, but somehow this is not probably looking the way I wanted to. But anyways, so you have a positional encoding, and then you have a normalizer, and then you have a feed forward network that um, has been provided input by a self attention mechanism. That kind of, so when I say so attention here is the word. Attention is, that is why the paper was also named Attention is All You Need. You give attention to what is very important. So let's understand this self attention mechanism. And because of self attention mechanism, transform became so famous that it gave birth to the uh, LLMs or large language models. So what does attention do is it computes relationship between all pair of positions. So that's what I said, river bank and bank to withdraw money. So bank and money, it tries to compute a relationship between them, and every word attends to every other word. So if you don't add money in after bank, you will never understand whether I was talking about the river bank or a financial institution bank. So their attention model tries to get the context by building a relationship between the previous word and the next word. So there are three vectors per input: the query, key, and value. So attention tries to understand how much query matches each key, and then it tries to see what am I looking for. So when you ask who is the PM of India, it looks for PM and India. So PM and India becomes query. Key, what can I offer? Do I have information on PM? So it tries to see PM means Prime Minister. What information does it have on India? And value, what I actually contain. So PM of India is Narendra Modi. So that output has to come as Narendra Modi. So that is how it tries to, create these vectors and see what information is being given to me, what information I have, and how can I combine them and get an output so that it is closer to what the user is asking. So if you see BERT versus GPT, BERT came in 2018. Again, it was a paper by Google. BERT stands for bidirectional encoder representations. So these are pre-trained transformer models. So BERT is already trained on a very, very huge amount of data, and I'm sure uh, people who have used BERT, they know how efficient BERT is because of this attention mechanism. You have BERT uncased and cased, both large and small, present in Hugging Face. You can download and give it a shot. There are example codes also present. So what BERT does is next word prediction. So here, the example that I was talking about, the bank by the river. So bank can mean financial or river bank, both. But when you have added the river, since it tries to compute the relationship and it tries to uh, create, you know, uh, those kind of attention, it tries to predict the next word. So BERT works on an architecture of by masking the next word and trying to predict the next word based on the context. And that is how it is generating answers for you as well. When you ask a question to GPT, say you give a scenario and say, hey, you generate a story on that. It tries to see the previous context and masks the next word and predicts the next word. So GPT, I am sure every one of us has used it on a day in day out basis. So it stands for generative pre-trained transformer. Again, very efficient. Here the architecture is decoder only. Like I said, it's a next token prediction. You can generate text, you have chatbots, and then you have code completion, everything. We'll talk about those use cases. So for example, if you give it, and what you see in Google autocomplete is also somewhere related to this. So Bank by the River was, so GPT predicts beautiful, crowded, muddy, everything, etc. So it knows the context that you're talking about a river bank and what all a river bank could be. It could be beautiful, it could be crowded, it could be muddy, it could have lot of boats or lot of birds, etc., etc. Right? So bird we have uh, different variations for different use cases. You have a bird for NER also, I guess. So and GPT today we have GPT 5.0 that is released, that is working, right? So transformers, we have applications that are beyond our text. You know, Chat GPT and Claude is a conversational AI. You can generate images of yourself, and you can in fact generate imaginary images of yourself. Like if you want you in an astronaut suit, you will get that. There is language translation that is happening. Code generation, it's just not, GitHub Copilot has evolved to a next level. You just have to give a prompt that I need this code, and you'll get the complete code written with comments and document summarization. Upload a PDF of 100 pages into GPT and ask it to summarize it within one paragraph. It is very efficient. Computer vision, you will see vision transformers that are doing a better job at surveillance. Then image generation, this is what I was talking about, DALI 2. In fact, there is a video generation that has come into picture by OpenAI itself, that is not yet released for public use, but you can actually create videos. Like if you want a college, if you have a college fest, and if you want to create a trailer or a teaser, you can just give the prompt and it will generate everything. No need of even Photoshop or any video editing software. To that level we have evolved. And then we have the visual question answering that is happening. You see most of the calls that come to you through service center are now AI based. I'm sure if anyone of you has taken a no broker subscription here, you'll get an AI call which sounds exactly like human and it tries to understand what you're talking. So, and then we have multimodal transformer applications where you can understand. So if you give a graph to GPT and say, hey, can you explain this graph? It will completely debug the graph for you, saying the sales were down, you could do this. It can give you suggestions also. And scientific applications, there are a lot of things, but one is the protein structure prediction, and the second one is molecular generation for drug discovery. Whenever you are trying to find a new drug for some kind of disease, especially when we were going through COVID, AI could and did help a lot for researchers who were trying to understand the RNA the coronavirus was. So very, very, very vast applications of transformers. People interested. In fact, go to ChatGPT only and ask the different applications. You will see a lot of real world based applications that are being used. Apart from that, deep learning, like I said, is being used in day to day life in every other company, be it e-commerce like Walmart. Okay, I was at a conference by Walmart. My sir, do I have time?
Yes, sir, you have time, sir. Enough time.
Yeah. Okay. So, a quick, you know, so Walmart organizes a conference every year called as Walmart Converge, and again, from the deep learning convergence, they have come up with Converge. What Converge does is they showcase what they have done in the space using AI. And this year they had a very interesting tool. One was there was one AI bot that was guiding blind people through the store and helping them pick up the right item. So it will be attached to the chest or hand of the blind person, and it will help you walk wherever you're walking. It will tell whether when there is obstacle, and it will take you to the sections that you want. If you upload a list, it will take you where it will navigate where to go in the store. Second was if you stand in front of a screen, it was called as skin analyzer or beauty analyzer. I'm not sure of the name. If anyone knows, please correct me. So that you just stand in front of the screen and it analyzes your skin, and it tells you what kind of skin type it is and what are the products that you need to use and what are the problems that you have and which dermatologist in the nearby area you should connect. So everything Walmart is doing in terms of AI. I'm not just talking about Walmart. E-commerce has, or any other industry, healthcare has taken a very big leap in using AI and neural networks in their businesses. So let's understand GANs. Now, GANs are very interesting because it's literally like you have there are two neural networks which are competing, or I should say, you know, discussing with each other to predict the output. So what GANs does is that either hello, I'm audible.
Yes, sir, everything is fine.
Okay. So what there are so for example, it kind of creates new realistic data from existing example. So it was introduced in 2014. So how it works is it creates fake data. So there is a generator that creates fake data from random noise. Then there is a discriminator that evaluates the data. The discriminator compares the fake data with the real data and tries to distinguish them. So basically, it's a self-maker checker algorithm. And then there is a feedback loop that happens. Based on the discriminator's feedback, the generator adjusts and improves the fake data and the process repeats. So basically, to understand GAN, there is three steps. One is first is generator. Generator creates a set of fake data, and there is a real data that you already have. Then discriminator evaluates data, and then it acts as a critic. It says, hey, this is real, this is fake, and it tries to distinguish them. And wherever it is not able to distinguish, it gives a feedback saying, hey, this is where I failed. And then it again creates a set of fake data to make it more distinguishable. So in gaming, especially, GANs have really helped, and in healthcare, again, like I said, most of these algorithms are out there in a day-to-day basis. That is something we probably can't see it because everything is happening in the backend. So there is two types of GANs that we have. One is the vanilla GAN, and then we have a conditional GAN. So conditional GAN allows you to add any kind of condition for a specific type of outputs. And then you have the deep convolution GAN, that is the DC GAN. So DC GAN are used for mainly image generation because they use CNN instead of single layer perceptron. And that is the reason it is called as DC GAN, because it is a deep convolution GAN. And then there is a super resolution GAN, which is probably working on the low resolution of images that you see. So super resolution GAN is useful when you have images from CCTV that are very blur and all. That's where it is very helpful. And then we have autoencoders. Basically, every time you present a data, all these data is presented as a representation, and these encoders do nothing but they represent the data in a way that the model understands. So, excuse me. So, whenever you pass the data to any kind of model, it has to be, passed in a way that the model understands. And encoders and autoencoders do the same thing, that they have the ability to do that in so that your dimensionality is reduced, and better information is passed to the model, and once it is decoded and the output is structured, you get the accuracy very high. To put it in a very layman term, so autoencoders are nothing but it's a learning that happens. It's efficient data representation learning, which compresses the input into a lower dimensional latent space. So the latent space that you see here is basically it is compressed. You have input data. For example, if you had six different features in input data, x1 to x6, and in the hidden layer, what it does is it reconstructs into a latent space of a1, a2, a3. So 6 reduced to 3. The representation of these input is done in a1, a2, a3, and then when you put it through the decoder, you have the output that is reconstructed. So autoencoders are used in anomaly detection, image denoising, feature learning, etc. There are different challenges. So when we talk about any kind of algorithm that we see, and when we talked about ethics and explainability in AI also, we saw a lot of challenges, and some of them are here too. So when I say that you don't, deep learning is a black box, not completely, but you have an issue of explainability when you're dealing with neural networks. So, but to understand the harder parts, for any kind of neural network, you need huge amounts of data, and then you need to have a proper labeling if you're dealing with supervised learning. And there is going to be a bias in the data which will be handled by the neural networks through various things. Computational challenges will be the GPUs that are required, and that is what I said. Though it started in 1980s, the first paper was 1983, if I'm not wrong, and then people didn't have enough resources how to come up with, and it was not easily doable on the paper. And then inference latency for real-time applications. So the traffic signal challans that you get are not immediate, they take time. So if you have done an offense now, it will take 12 hours to generate a ticket. And technical challenges, it will include hyperparameter tunings. We talked about learning rate. So learning rate is not the only hyperparameter. We have the number of layers, we have the number of hidden layers, what is the batch size, what is so all of these matter a lot when you're training a neural network. And vanishing gradients problem and debugging black boxes. This is what I was talking about. Since you don't have an explainability of what actually happened in the neuron, it becomes difficult to understand how this output was generated. So I'm sure we all know the bias variance trade-off, which is a classic ML problem that we have all faced. That if there is a higher bias, it could be the lower variance or vice versa. And then we have so because of this problem, there the model kind of overfits or underfits. And how do we manage this? So the problem is, if your training loss is low and the validation loss is very high, your model is overfitting. Your training loss is low, validation loss is also low, means the model is able to detect the patterns even in unseen data. It's a good fit. If the training loss is very high and validation loss is also very high, it means the model is underfitting, means it is not able to actually capture the pattern. And when we say overfitting, it has generalized the pattern. And if the training loss is high and the validation is loss is low, then there's a data leakage. Probably some kind of like probably all the samples have gone into training only, or all the samples have come into testing only. So this, to balance this, we have regularization. So there are different types of regularization techniques. So one is the dropout. What it does is it randomly deactivates neurons during training. So there are informations being passed in neuron. It randomly selects one neuron and deactivates and chooses not to pass any kind of information there. And then you have L1, L2 regularization, which penalizes larger weights. So if you have any neuron is given a very larger weight to any feature, it kind of penalizes it, and then it tries to do best set of feature selection. Then we have early stopping method, which kind of helps uh, that if you're training the model and if you see the validation loss is increasing, you stop the training. And then you have data augmentation, which is the last technique you should apply, because it is basically creating artificial or synthetic data. Now, this is what I was talking about, ethical considerations. We have to be very clear about it, because rest, like I mentioned, and we have bias and fairness, privacy concerns, and transparency is what I was talking about. You can't have why a decision, cannot explain why a decision was made, which is critical for healthcare and finance and legal, so that they know why this output has come, right? And There are a lot of deep fakes, like I was talking about. Grok has been, and I think now it has stopped, but for the last week, Grok was pretty being used to generate deep fake images of people. And we can have autonomous weapons which can cause huge amounts of destruction. So responsible AI development becomes a huge step when you're talking about deep learning models. So this is what I was talking. If again a scenario, if you are building a hiring AI that reviews resume, the bias that might exist in historical hiring data is a gender bias. How would you detect if the model is discriminating? Will you be able to explain why a candidate was rejected and what happens when the model is wrong? So this penalizing becomes very important. When your model predicts something wrong, you have to penalize it. Future trends is, I think we have reached most of the you know places where we see deep learning has evolved into a very big revolution. So if you see multi-models, we have understanding both text and images, text-to-image generation, vision language models. All these are already exist, but they'll get better and better. So smaller model for edge devices is you will probably see small neural network running on your smartwatches also in coming days. Apple might be the first one to bring it. And then you have LLMs which are giving you pre-trained something like Llama, which is a 140 billion parameter model that is already pre-trained on so many parameters that you need not train again. You can directly use it. And in future, we'll see autonomous agents. Agentic AI is a big thing now, and we are building agents for everything. You can have an agent just to conduct a session for all of us, you right? So agents are a very huge thing, and personalized AI assistants again are on the picture. So deep learning has reached some of these areas, and some of these areas will be very emerging. This is the code walkthrough that I had. It's a simple neural network. It's this. So one thing I tell people when I take interviews is, or when I talk to people back in my college, also students, I tell them don't worry about coding any machine learning or neural network thing because it's a very small line of code. It is very simple to write a neural network code. But what matters is understanding that neural network. When you say that I am putting 128. What is that 128? Sequential. What is that sequential mean? How many layers are you putting? So what is the so criterion is your cross entropy loss. Optimizer will be your Adam optimizer. And epochs is how many times you'll be running the training. So each epoch will have some validation loss, some training loss. So though the code looks very simple, but there is a complete concept of a human brain-like architecture hidden inside this. Okay, I have a simple quiz here before I end. Can anyone answer each of these questions quickly before I close? I think I have 10 minutes. I'll take another 2 minutes. First one, can anyone answer? What does a CNN use instead of fully connected layers? It's pretty simple.
Convolutional filters.
Yeah. Question number two.
Vanishing networks.
Yeah. Um, Question three. Anyone?
Format.
Simple. CNN.
Machine translation, sir. We are talking about
Machine
machine translation.
Transformer.
transformer.
Yeah. And what does the generator in GAN do? We just
Generates fake samples, both A and B.
uh, so the generator just generates fake sample. It doesn't do both A and B.
Mm.
So first one, as ma'am told, it was convolution filters. Second one, again, vanishing gradients. Third one was seed transformers. When we say machine translation, it requires a encoder decoder architecture. And fourth is B. So generator doesn't do discrimination from real to fake. That is a different module, sir. So key takeaway, neural networks learn through. So like I said, there are two ways a neural network learns. One is a complete forward pass, and then there is back propagation only if your loss is very high. Activation functions add non-linearity, which helps in understanding complex patterns and not just the linear patterns. Loss functions measure our prediction quality, and hence we can use back propagation or not based on that. So architectures, if you see, there are four major: CNN, RNN, Transformers, and GANs. And GANs are best for generation or tasks. Transformers are for long range dependencies, machine translation, and based on transformers only you have GPT and every other advanced thing that you see. RNN and LSTMs were best for sequences, but they have a problem of short-term memory, and hence transformers came into the picture with attention is all you need. The attention mechanism kind of builds relationship with each entity next to it and previous to it. And CNNs use a convolution and pooling method to for classifying images. So in images, you have a lot of information that's not required. To remove that and to only come up with the features that you need, CNNs are used. So you can start using these architectures. I would suggest go and start with a simple CNN for handwriting recognition, and then ask the students to go and download a complex model transformer like BERT and see how it functions for a simple classification. It would be a simple classification problem, but again, here the explainability still is not completely there. So if you ask why this output came, we can't really tell it. Uh, I think these are some resources that I had, but Kaggle would be a good start for students. GitHub also has, and online courses are present. Stanford already has NLP with deep learning, so students can go enroll for this and they can take good advantage of this. I'm sure nobody is reading books in this savannah, but yeah, if someone's interested, these are some books. PyTorch and TensorFlow. PyTorch is by Facebook. TensorFlow is by Google. Initially, TensorFlow was complete run, so you couldn't do parallel processing, but now you can do in TensorFlow and PyTorch as well. So based on the flexibility and convenience, anything can be used. And I conclude here. So this was my last slide. If you guys have any questions, please feel free to.
Dear participants, if you want to discuss anything on neural network, so I request you people to have a discussion with Pawan sir. So frankly telling, sir has nicely walked through the concepts of neural network, starting from perceptron and up to LSTM and GRU. So many technical concepts were covered. That is the architecture of CNN and architecture of LSTM. So such kind of things have been covered by Pawan sir. So actually, those who are already taking the subject deep learning and natural language processing, I think you have certain knowledge on these things, that is CNN and RNN. But those who have not taken and willing to take these subjects, so they need to have knowledge on all these things. Why should we apply? Where should we apply CNN? Where should we apply RNN? And what is the advantage of having LSTM? So such kind of things are very useful though for beginners, those who have not taken the subjects like NLP and deep learning. So I hope you got benefit from this session. Actually, sir nicely explained all these things with patience. So, Pawan sir, I thank you so much, sir, for your time.
Yeah, thank you for the opportunity, and I'm sorry for the audience. I both the days because I was a little on a travel, my camera was not working, and my PPT also failed given that. So, but thank you everyone for patiently sitting through this 1.5 hour session. I'll share my LinkedIn and other profile with my sir. If anyone wants to contact further, please do reach out to me. But this was an excellent opportunity, and if there were any mistakes in what I explained, please do forgive me for that. And thank you very much. And I hope you guys all have a nice weekend.
You are welcome, sir. Thank you, sir.
Thank you.
Mahesh, sir.
Hello, sir. Sir, am I
Sir,
audible?
sir, good evening, sir. Good evening.
Good evening, sir. Am I
Okay.
audible, sir?
Yes, sir, you're audible, sir. You're audible. Dear participants, let us move on to next session. The session will be taken by Dr. Mahesh, sir. You already know Dr. Mahesh, sir, was gave introduction on agentic AI. So now again, sir has taken the session on some other topic, and also sir would like to explain few things on agentic AI again. So after that, sir is going to take on a topic uh, that is different pedagogical approaches to teach AI. Mahesh sir, once again, I welcome you.
Yes, sir. Yes, sir. Thank you. Thank you, sir.
Okay, so you can continue, sir.
Yes, sir. Very good evening to all present over here. I hope I'm audible properly. If my voice is not audible, anytime you can stop and then you can uh, ask me later. Okay. I think s- this is the last session of the FDP, if I'm not wrong, according to the schedule. Uh, in this schedule, in this case, I have been given a topic called. Just give me a second time. I'll share my screen and then I will start. Just 1 minute. Whether the screen is visible?
Yes, sir, it is visible.
Okay, okay, okay. Ah, so today I have been given a topic called curriculum design, pedagogical approaches for teaching artificial intelligence. Let's see. Hmm. I think screen is visible properly, if I'm not wrong.
Yes, sir, it is visible, sir.
Okay, okay, okay. So before I start with the session, I think this is the second time I'm coming in this particular FDP. I would like to thank one more time because I have been given two sessions. So I would like to thank organizers before I start with this session. In this session, whatever the things we are going to discuss, mainly two things are there. One is called as curriculum design, and another curriculum design and all. Many of us may not be having that opportunity to design the curriculum because many of us, including almost you can say that everyone of us are working in a framework where every college is affiliated to some university, and the university used to design the syllabus, and we used to follow that syllabus, and that is how actually the things will happen usually. Uh, uh, but the thing is, if you get some time, or if you are in a part of BOS or something like that, you can do follow some of the things what I am going to share in this presentation. That's the first thing. But the second one is the pedagogical approaches. That is anyone can follow. You may or may not be a part of BOS member. Whenever we teach artificial intelligence or any other subject, we need to follow some pedagogical approaches. So I'm going to go with some of the pedagogical approaches for teaching artificial intelligence with respect to this subject. I'm not going to talk about other subjects and all in this session. With respect to artificial intelligence, if you want to teach, what kind of pedagogical approaches you can follow and so on. So that is what the main two things I'll be discussing. If time permits, as sir said, we will see the same example one more time, what we have discussed in the previous session. But we will see if we need at least half an hour for that particular example. So we will see. Yeah, first, we will try to finish this topic because this is the scheduled topic according to your FDP and all. So we will finish it first. So this is what actually the plan is. I'll be starting with AI evaluation to AI in education. In many of the sessions, you must have gone through this AI evaluation. So I'll not be touching of this one again in detail. Briefly, I will tell you. Then, why AI education matters? So that is the second point what I want to discuss with you people. What are the challenges the faculty is going to face when we are going to teach this artificial intelligence? Why do we need different pedagogy for teaching artificial intelligence? That is the next point. Next, we will discuss briefly about the design of AI curriculum. So, what should be there in AI curriculum, and what are the different, I can say that the levels and so on. So, those are the different things we will try to discuss. Next, we will try to discuss pedagogy, like how can we teach artificial intelligence, different methods in pedagogy. How can we assess artificial intelligence subjects or the curriculum? What are the ethics and integrity to be followed when it comes to artificial intelligence subject? And then finally, I will discuss about implementation and outcomes of artificial intelligence subject or the curriculum in general. So we'll start with the first thing, that is AI evaluation to AI in education. We have seen this point. You must have seen this particular point in this FDP many a times, like how this AI has evolved over a period of time. I'm not going to go in details about this one. Like it has started with rule-based systems. That's a core artificial intelligence. Later, it has evolved to the machine learning, where everything is with respect to data. Data is given as an input to the machine learning algorithms. It will identify some of the patterns from that data. It will make some predictions, classifications, or some kind of things like spam detection, disease detection, or disease prediction, you can say. So these are the things where a part of this machine learning. Later, what happened is this machine learning has been evolved to, there is another thing, there's something called as a deep learning. I think that was the previous session, if I'm not wrong. Deep learning talks about, you can say that image recognition, speech recognition, you can say that natural language processing, and so on. So that is the breakthrough in this artificial intelligence, which has given a lot of application. Daily, we use many applications in our mobile, in our household applications, or anywhere we use many applications, but we don't know the deep learning is working behind the scene. Whenever we open our mobile with the help of fingerprint or face recognition, or whatever it may be, everywhere the deep learning is working behind the scene. After deep learning, I think we came across something known as generative AI. Generative AI is where we are going to generate the different content like text, code, images, or video based on the prompts, whatever the user gives. The best example is the ChatGPT, Gemini, and so on. So we use these particular things for doing the generation of content and so on. And finally, right now we are present in this era, agentic AI. These are the autonomous agents. They work based on the goal. Whenever we specify the goal, they will divide that particular goal into different tasks, and each of those the per task will be completed step by step or parallelly. And at the end of the day, we will get the output here. So that is the agentic AI. So why I'm talking about this one is when we start building any curriculum or pedagogy for artificial intelligence, we should know where we are currently standing. We should not design the curriculum considering the rule-based system. We should not design the curriculum considering the machine learning. We should design the curriculum considering the currently where we are studying, and we need to think of the future, like what can happen in near future. It is very difficult to predict what will happen in down the 10 year down the line or 15 year, but at least we can think what will happen 2 years, 2 year down the line, and then based on that we need to design this curriculum. So that's the reason I have added this particular point here. As AI systems now reason, generate, and act autonomously, our syllabus should be like this only. It should not be with respect to rule based systems or something like that. So that's one point we need to remember here. And the second thing is AI is evolving rapidly. That's another very important thing we need to remember. Our syllabus, we usually revise it 3 to 5 years, once in a 3 to 5 years. But our this one, like AI, is evolving every few months, or you can say that few months only, not every few months. Every month it is, you can say that evolving. So there is a very, can say that great or a dangerous gap between the way the industry uses the artificial intelligence and the way students learn outdated the AI concepts. So what we are teaching in classroom is almost, I'm not saying that everything, but with respect to artificial intelligence, many of the things are, you can say that outdated right now, because still when we go with our syllabus, what I used to teach a year back or something like that, we used to teach how the tic-tac-toe game is played, how the chess game is played, how that particular n-queens algorithm works, the search algorithms, and so on. Of course they are the need for artificial intelligence, but at the same time we need to include the current technology as well as the current trends and so on. So that's a very important thing should happen. Curriculum, the traditional curriculum focuses on tools, not the thinking frameworks. The meaning of this one is usually what we say in the classroom is use this Python library, use this algorithm, do the model training, and so on. So, and come up with the results. That is how actually the current syllabus or a curriculum works. But what actually required here is how to frame the problems. Because if you want to solve any problem or whenever you see something in front of you, first and foremost thing is you need to frame the problem correctly. The half the problem of framed correctly, it's a half solved. That's how the things are there. So better to frame that particular problem correctly, decompose that particular problem into different tasks, and then evaluate the outputs. And you need to based on that AI outputs, we can deploy that particular thing in real world. So you should not think only about the libraries and all, because if you want to generate a code, ChatGPT can do that one. But the thing is, framing a problem is very important here. Decomposing that problem into different tasks is important. So we need to teach such kind of things in the classrooms and so on. So that is what I'm talking here. AI education must move from technology exposure to cognitive skill development. So that is the next thing. We should not just talk about the can say that scikit-learn library. We should not just talk about the TensorFlow library. We should not talk about the data set and ChatGPT. As said earlier, we need to think of the problem formulation, critical questioning, reasoning, and the validation of that reasoning. The very important thing is the ethics should be included in AI education. And whenever we get the final decision, there should be some kind of justification to that one. We should not generate the can say that thinking engineers. We need to we should not generate just the operators. We need to generate the, can say, the thinking engineers. That's what we can say that. The next one is the curriculum, pedagogy, and assessment of artificial intelligence evolve, can say that parallelly, because each and everything is interrelated with one another. So they should go hand in hand. Then only we will be able to teach the artificial intelligence the properly in this particular case. The next point, what is we need to discuss is why AI in education matters. Why AI is required in current, can say that education system. So when we talk about artificial intelligence, it is not only for the computer science people, the one who is studying the Bachelor of Engineering or Bachelor of Technology and in computer science should study the artificial intelligence. No. At the same time, artificial intelligence is no longer limited to a software companies, research labs, tech startups. It is not limited to these particular kind of things. Not limited to this computer science background students or something like that. Because AI is actively transforming each and every field what we can see in real world. Because you can see some of the examples of healthcare. In healthcare, we can use AI for diagnosis. We can use it for radiology. We can use it for drug discovery. We can use AI in agriculture for crop prediction. We can use it for pest detection. Similarly, we can use it in finance for, you can say that fraud detection or credit scoring. At the same time, we can use it in the manufacturing industry for predictive maintenance, autonomous, and so on. So AI is present in every field. Whatever you consider, everywhere it is present. So that's the reason it should not be limited to only to the computer science student or something like that. We should make it for every, you can say that the background where because it is present everywhere. Each and every student should have some kind of knowledge. It's not that they should code, at least they should have some knowledge. Because when they use this thing in their field, at least they should understand what is the output coming, and they should be able to they should be able to understand that output. So that's the reason some kind of knowledge is necessary in this case. That's what the AI is transforming every domain. The second one is industry demand for artificial intelligence skills here. So industry today is not asking only for the AI developers or the data scientists. They are asking for the engineers who can make work with AI tools, managers who can interpret AI outputs, or you can say that the professionals who can make decisions using artificial intelligence support and so on. So even the entry level jobs nowadays expect the AI awareness. So when we go for when our students go for giving interview and something like that, they used to say that many of the interview have asked the concepts related to artificial intelligence and all. So what is expected in the interview is AI awareness. Data driven thinking is required, like how the data is used in artificial intelligence and how it is changing the world. Such kind of things are known to each and everybody. This without these things, it's very difficult to I can say that getting the entry level jobs also. So AI literacy is becoming a baseline for employability skill, not a specialization nowadays. AI literacy is a becoming a core graduate attribute. That's a one more point you can consider here. That is earlier core graduate attributes include like communication skills, problem solving, teamwork, critical thinking, and so on. We were having different graduate attributes. We have worked with NBA. You must be aware of all these things. But nowadays, AI literacy joins this particular list. So if you are from a computer science background or not, everyone should know some knowledge about us. Everyone should have some knowledge of artificial intelligence. AI literacy does not mean, again, I'll point this thing, AI literacy does not mean that everyone should code neural networks. Everyone should code, can say that CNN or something like that. No, it is not like that. What is required here is everyone should understand what AI can do and what it cannot. That is the very first thing everyone should know. Everyone should know how AI systems make decisions. That is the very second point should be known to everybody how AI is can say that able to collaborate with other can say that the fields so that it can solve the real world problem. So these are all the things that should be known to each and everybody when they go for when they finish their engineering or something like that. Now, the second one is AI impacts, artificial intelligence impacts employability and lifelong learning. AI is changing the job roles rapidly. I think all of us know that thing. Some tasks are automated. Nowadays, testing industry is getting automated. New roles are emerging due to this artificial intelligence. At the same time, existing roles are augmented by artificial intelligence. So all these things are happening in the industry. So what should happen is every graduate must be prepared for continuous reskilling, not only skilling, reskilling, learning new tools repeatedly, adapting to AI driven changes throughout their career. Then only they can survive in the industry, otherwise they don't. So we need to teach all such kind of things in our, you can say that, or we need to include all those things in our curriculum. Then only they can inculcate all such kind of things and they will survive in the industry. So education must focus not just on current tools and what the current technology is working, but on the learning how to you can say that how to learn with AI, adapt to the future's AI systems, and so on. So that is the very important thing. So this is why the lifelong learning capability is critical in artificial intelligence. And it's a very important thing. I think I have told already. Non-CS disciplines increasingly require AI awareness. So we used to say that the AI is required for only CS people or something like that. It's not like that. Along with the CS people, everyone are expected to have some knowledge about AI. Otherwise, it's very difficult for them to can say that uh, survive in the industry. Because I'll give some quotes or some examples over here. Let's say that there is a mechanical engineer. Nowadays, mechanical engineers using this AI for design optimization. So what it means is the if a particular mechanical engineer doesn't know anything about AI, it's very difficult for him to survive in the industry because industry is using the AI for doing the design optimization. So that's the important thing here. Civil engineers use AI for structure monitoring. The commerce graduates are using it for analytics. At the same time, if you consider life science students, they are using it in bioinformatics. Humanities use this in language and content analysis. So if you take any can say that the field or any graduates, everyone is using this. Can say that AI. So that's the reason. Once again, I say it is not limited to the computer science disciplines. It is this knowledge should be required for each and every graduate. So that's the reason we can say that AI education is very important. Uh, or nowadays, you can say at least future many of us may not be aware, but right now AI in education is very important. Now, till now we have seen like what is AI and why AI is important in our education. Now, the next very important thing is what are the different challenges our faculties are facing because of this AI and all. Most of us are trained, you can say that on a stable syllabus environment. We have been given a syllabus. That particular syllabus will stay for at least 3 to 4 years or 5 years or 6 years. We have to teach the same thing over a period of time. But what is happening in artificial intelligence is everything is changing at a drastic rate. So because of that, there will be a lot of challenges a particular faculty faces when they teach artificial intelligence. Very first thing what we can say is rapidly changing tools. So AI tools change. I'm just not talking about the technology. I'm talking about all everything like the algorithms or the way the same what we have designed today it will change tomorrow. So that's the reason I'm saying rapidly changing tools. AI tools change faster than academic calendars. Uh, University syllabus approval cycle, as said earlier, it will be 3 to 4 years. Faculty training programs, faculty training happens once in a year or something like that, but the AI tools change every month or something like that. So they are rapidly changing. So this creates a stress in the faculty members like what tool should I teach? Should I teach this tool or should I teach that tool or should I teach something else? So there is a stress among the faculties. At the same time, what if students know a newer tool than me? Of course, this is happening nowadays. I'm not talking or I'm not blaming any faculty or something like that, but including me, our students are more smarter than us. They know better than us. They know the better tools than us. So that is again creating a stress on the faculty. Will my content become outdated quickly? Of course, that will happen, but we have to adapt to that one. So this is the first challenge the faculties are facing when they teach artificial intelligence. The second thing is there is a lack of structured pedagogy. When we talk about pedagogy, for almost all other subjects, when we talk about mathematics, almost we can say that this is how actually we need to teach the mathematics and so on. So that kind of things are there. But when you talk about artificial intelligence, there is no universally accepted AI teaching pedagogy is presented. So most teaching relies on the tutorials, tool demonstrations, and online videos. Uh, what is missing here is clearly learning progression is missing. Pedagogical models for reasoning with AI is missing. Framework for human AI collaboration is missing over here. So, because of all these things, what actually happens is uh, we it may be difficult for us to teach this AI as effectively as expected or something like that. So what can happen over here is that these kind of FDPs. I don't know how to what level it will help, but such kind of FDPs, such kind of training programs will definitely give some idea to we can say that the faculty members to teach artificial intelligence effectively. Coming back to the next challenge that is called that is with respect to the assessment. So when we talk about assessment, assessment of other subject is and assessment of this AI is quite different because nowadays almost everything is generated so quickly that the students will copy and paste it from the chat GPT or Gemini and then they will submit the things. So it's very difficult to verify that thing, whether the student has done it or whether it has been done by the AI system or something. So that here the assessment is getting difficult. It is not only with respect to the AI system, it is with respect to other subjects also. In uh, earlier case, we used traditional exam system, we used to conduct the exams, internal and then the final examination, where the people will memorize the things and then they used to reproduce. So such kind of things will not work with respect to the artificial intelligence. We should have something different in artificial intelligence. We will see later. Difficult in keeping curriculum up to date. Yes, I think I have already discussed it. Curriculum revisions takes 2 to 3 years or 4 years, sometimes 5 to 6 years. Nowadays, of course, universities are changing it every 2 years or something like that. But still, that is not so up to date with respect to the AI, what is evolving in the industry, because AI evolves, as said earlier, in a month. If we keep adding the new topics to the existing syllabus, that is also a problem because what will happen if I go on adding the new topics to the existing curriculum? It will create a overhead and the faculties struggle to cover to the depth what is expected. So it's not that we just go on adding the content. That is not the correct thing. What should happen is constantly adding the new topics is not a we can say that the solution over here. The solution is we cannot add the topics constantly. So what we can do, that is we need to design a flexible and modular curriculum where we can teach the conceptual foundation that remains stable. So that is how actually we need to design our curriculum. We will see what or how we can do it at the later stage. But we cannot go on adding the topics every now and then. We need to design a flexible and modular curriculum. That is the only solution exists over here. The next one is the lack of industry exposure to real AI systems. Many academic examples, what we see in book or in examination, they are clean, small scale, and idealized. They are ideal solution. You can say that the questions. We don't have much of thinking for each and every question or something like that. But what industry expects is they expect to understand the messy questions, large scale questions, integrated with the business constraints, subject to ethical and legal issues, and so on. That kind of things are not at present in our curriculum. So that is the another problem over here. At the same time, teachers like us, so we don't have much exposure to the industry environment. So somehow we should have been given some opportunity to get some insights from the industry so that it is easy for us to train the students in the classroom effectively. Managing the student over dependence on AI tools. That is the another challenge what the faculty face, because nowadays students are using AI for writing code, writing assignments, writing whatever the questions will give, like explain the so and so concepts and so on. But it's very difficult for us to control such kind of things. Because of these things, what is happening is there will be less learning happening, because they just reproduce what is present in that output and they will get the marks. That's what is happening over here. That is creating a over dependence of students on AI tools. Somehow we have to manage it. Again, this is a very challenge in front of the faculty members here. Coming back to the next one, designing assessments that test the original thinking. That is what actually the extension of the previous point. What people are doing right now, they are depending on the AI tools for generating their assignments, codes, and all those things. Now, how to test the original thinking, whether it is original or it is being copied from somewhere. So to get this particular kind of thing, it's very difficult for the faculty member. That is what I'm trying to say here. How can we test the original thinking? We will see it later when we talk about pedagogy and all. We will try to see these things. So somehow I'll try to speak on each of these things, or how can we solve these challenges at the later stage when we talk about pedagogy and all. Now, the next thing is when we talk about, we can say that AI needs a different way of teaching, because what we have taught till now is with respect to static subjects or the syllabus, because AI is changing regularly, or you can say that every month, it needs a different strategy to teach in the classrooms. The reasons are these. The first one is AI is interdisciplinary. AI is not a single discipline subject. As said earlier, it draws things from, you can say that the statistics and linear algebra from mathematics, algorithms and data structures from computer science. Whenever we want to solve some real world problem, we need a domain knowledge. For example, if you're solving a real world problem from healthcare, agriculture, or finance, we need to have some domain knowledge, because being an engineer, you may not be aware of what is happening in the healthcare and how to solve healthcare problem. You know how to code, how to design the models and all, but you don't know what is the how the healthcare industry works, how the agriculture industry works, what leaf is having what kind of disease, that is known only to the person who is having the domain knowledge. So because of this thing, the teaching AI is bit difficult. That's the first thing. Second thing is why AI teaching is different, needs different thing is we need to focus on thinking, not coding only. Till now, whatever we are talking is like we give some problem definition to the students. We ask them to come up with a code which will give the output. But that is not sufficient nowadays, because in the earlier days that was perfectly fine. I'm not saying that it is wrong or something, because they used to struggle to write that particular code. But nowadays that is not happening. As said earlier, the generative AI tools are available. We can give the prompt; it will give you the code. But where is the thinking in that case? So that's the reason. What is required over here is focus on thinking, not coding. In earlier days, that was not required, because code only people will think a lot and then they will come up with a proper, you can say that the results and all. But nowadays, because of AI, everything is available at our fingertips. So we need to shift our attention from coding to thinking. So that is the reason different strategies required, I think. AI concepts evolve faster than the textbooks. I think that was already told. AI is evolving every month. So because of that, different kind of teaching strategy is required here. Learning outcome focuses on reasoning, not memorization. In AI education, memorizing formula is not useful. At the same time, memorizing the steps is insufficient. Why? Because uh, we don't need to remember all these things. Everything is already generated by the AI tools. So that's the reason we need to inculcate something like this. Why this particular model is working? For example, you're using a CNN model, you're using a BERT model, you're using some other models. Why this particular model is working on the given data set? Why it is not failed on other data set? So such kind of things should be there while teaching, or we need to consider these things while teaching the AI. How these results are coming, whether these results are, we can say that justifiable to the real world, or we need some thing else so that we can justify these things in real world. So such kind of things are required. So reasoning is required here, not the memorization. So that is the reason some different strategy we need to follow here. AI requires iterative experimentation. Of course, many other subjects doesn't require this one, but if you look at the AI, we cannot build the model in one shot or something like that. It is built once. You may get some kind of results. You may get your model is working in some way. We have to understand whether the model is working fine on that particular data set, whether it is justifiable or not. We need to do if it's not working, we need to tune the model. We need to do the hypothesis testing. We need to analyze the failures, this, that, and all. We need to do it again and again until we get we can say that the better results or better justifiable results, I'm saying. That's a very important thing. So we can say that AI is process oriented, not outcome only oriented. It's not that we should get only the result, like this is the X class, this is the Y class. No, we should be able to justify why it is giving you X class, why it is giving Y class, and so on. So that is what the thing should be there. And the last and very important thing is when we talk about AI, ethics cannot be treated as an optional topic because AI influences the people's lives, fairness, privacy, safety of individuals. So, because of this, ethical concerns are not add ons in teaching artificial intelligence, they are the core of artificial intelligence. So, that is the reason what we need to do is when we design an artificial intelligence curriculum, we need to include ethics. That is the only thing. In our syllabus or curriculum, yes, we have ethics subject, one or two subjects that is of can say that multiple choice questions will be there in the examination and so on so forth. But what is required here is in every topic, every subject, we need to include ethics. That is the only solution because this artificial intelligence is influencing the common people's lives, common people's privacy, common people's safety, and all. So that's the reason we need to include ethics. The student who knows the ethical issues while designing the artificial intelligence systems, he will design a better system. So that's the reason ethics is the core part of the AI curriculum nowadays. Now, what we did till now is we have discussed what is AI, what how AI has evolved, why AI is required in current education. It's very important in the current education system. So these are all the points we have discussed. Along with that, we have discussed like what are the challenges the faculties are facing, why it needs some different strategy to teach artificial intelligence and so on. Now, what we do is we will shift our attention to something called as how can we design AI curriculum. That's the first thing. Second thing is how can we teach AI effectively? That is the pedagogy. So that's another thing we will discuss. And then the next point, what we are going to discuss is how to assess the AI learning and how to integrate ethics and responsible AI design in our curriculum and so on. So these are the different points what I'm going to discuss from now onwards. At the same time, when we build this curriculum, we should make sure that AI courses for not for only CS students, it is for non-CS students also. Now, the NCERT is including AI in the high school level also. I think you must have seen the syllabus of NCERT, but they are including AI in the high school level also. So that's the reason AI is very important nowadays. Now, this is the end-to-end framework for, we can say, that teaching artificial intelligence. Here, we need to talk about the curriculum, pedagogy, assessments, ethics, and implementation. So these are the five core components of what we can say that end-to-end framework for teaching artificial intelligence. So when you talk about curriculum should be designed modularly, I think layer by layer or something like that. It is usually divided into three groups or the three layers: foundational layer, core layer, and applied layer. So that is what about the curriculum. Second one is the pedagogy. We will discuss each of these things at the later stage. It should be experiential, project-based, agentic learning, and so on. Assessment strategy should be something different. It should be continuous, as well as the different kind of rubric should be designed. Uh, Ethics and responsible AI design. We should consider the privacy, transparency, safety, bias, and all those things while teaching the artificial intelligence. Implementation and faculty readiness. That is a very important thing. We can design curriculum in any way. We can design the pedagogies, we can design the assessment strategies, and everything can be done. But if the faculties are not ready to teach, or they are not skilled to teach the artificial intelligence, everything will go into, I can say that main. At the same time, we need sufficient infrastructure. Upskilling of faculty is required. Industry integration is required when we talk about AI and all. And the last one is the outcome. So what happens over here is if you follow all these 5 points, we will get skilled, ethically responsible, and industry-ready graduates. So when you follow a proper or when you design a proper curriculum, if you follow better pedagogies, if you include very good assessment strategies and ethics and responsibilities of AI is included in our, I can say that the daily classrooms, definitely we can come up with a skilled, ethically responsible, and industry-ready graduates here. So now what we do is we will try to discuss each of these points. Like we will start with curriculum design and then we will discuss each of these points. So as said earlier, AI curriculum should contain, it is divided into mainly three, I can say that the things. The first one is something known as the foundational layer. Second one is the core AI layer. And the third one is the applied AI layer. So why it has to be done is, I think I have said, you should not go on adding the topics to the AI curriculum on a regular basis. That is not a good thing. What should happen is the curriculum should be modular and flexible. So that's the reason it has to be divided into three groups here: foundational, core, as well as the applied AI layer here. Now, what is present in foundational layer is it's an entry point in to the AI education. It's an entry point. So when it is an entry point, we should not include. We can say that the heavy mathematics over here, heavy. We can say that the AI algorithms and all. So what we need to do is, or we can say that the purpose of this layer is to build the intuition and remove the fear from the students about the artificial intelligence, because when they come and see big codes at the initial classrooms, then definitely they will get can say that get they may get fear or something like that. They may go out of that particular can say that they study and all. So that thing could not happen. So first we need to build the intuition as well as we need to remove fear from the students. So that should be the main goal of this. You can say that our the first layer, that's the foundational layer. So what should go here? So when we talk about foundational layer, what should be there in this foundational layer? It's not that we can list each and every subject over here, but what should go here is in this particular layer, we should have what AI is or what AI is not. That is what AI can do and what AI cannot do. That is what we need to teach here. It's the first thing. So related to this, we need to put the syllabus. We need to add some mathematics so that they will get the probability and how this probability play a very important role in this artificial intelligence. So maximum part of artificial intelligence depends on this probability. So probabilities, statistics, and all those things should be taught at the initial level. And it should not include the heavy mathematics at the initial stage. That's another very important thing we need to remember. And we need to introduce few algorithms at this point of time, and basic ethics and social implications should be added over here. As said earlier, the ethics and the social implications should be part of every, you can say that the subject, they should not be kept as a separate subject, as what exists in the current, you can say that the things. Because this AI systems, as said earlier, they influence the people lives. As said earlier, they influence the privacy as well as the safety of every individuals. So that's the reason we need to include ethics and social implications. What should happen here is the key design principle is the conceptual clarity over mathematics. Mathematics is required in artificial intelligence. Heavy mathematics is required, frankly speaking, but what is required, or what is the outcome of this foundational layer is the conceptual clarity. So what is AI? What is not AI? What is probability? How probability will be used in artificial intelligence? What are the different algorithms are there? How they give the better results? Which one is good? Which one is bad? Such kind of things should be there in this case. And this one is suitable for all disciplines, because, as said earlier, every discipline should know something about the artificial intelligence. So this foundational layer can be included as a part of every discipline here, including non-CS students. So I think I have said every graduate has the basic AI literacy. So once they complete this foundational layer, every graduate has the basic AI literacy. So this is the core part, you can say. So and this is suitable for almost all the students. Uh, Second one is with respect to, you can say that our second layer is, just give me a second time, one second. Okay. So second layer is the core layer. Uh, so it is next level of the AI curriculum. Here we add some technical depth as well as the reasoning. So this is what the main part of the core AI layer. So here, what happens is we teach, or the purpose of this one is to teach how AI systems actually work. So that is what we need to teach here. This is not like giving some problem definition and getting the results and showing those results to the user, no, or the students. No, how actually this particular model is working, why it is working on this particular data set. Such kind of things should be taught in this particular layer, you can say. Enable the students to reason about the models. That's a very important thing. Nowadays, when you go with the final year projects, we have seen, all of us must have seen here, they will come up with, let's take an example of spam detection. They will use some machine learning algorithm like support vector machine or decision tree or something else. And they will say that we got 80% of accuracy, 85% of accuracy. Some people say that 99% of accuracy, and so on. But the question here is, it's not that accuracy matters over here. What matters over here is why this model is working for spam data set, why it is not working on some other data set. So such kind of knowledge is required, or such kind of reasoning is required in the student. So such kind of things should be added in a core AI layer. So that is the second part of the things over here. Now, what should go here is like machine learning fundamentals should be included in this case, like supervised, unsupervised, reinforcement learning, and so on, so forth. Model evaluation and the different metrics over here, uh, how the model should be evaluated, what are the different metrics are available, which particular metric should be used for what kind of the problem, what kind of the use case, whether this particular, you can say that metric is useful for such kind of data set. For example, if you go with the fraud detection, maybe a credit card fraud detection, or you can say that insurance fraud detection or something like that, accuracy doesn't matter over there because the data is highly imbalanced. There will be hardly, you can say that 0.001% of fraudulent transactions will be there. Remaining all 99.99% of genuine transactions will be there. In such cases, we cannot go with the accuracy. We need to go with some other, we can say that the evaluation matrix and all. So that's the reason what we uh, need to include in this core AI layer is how model works, what are the different metrics are there, and what metric. It should not like what are the different metrics are there. If you just include that one, that is not sufficient. What is important here is how that particular model is, so metrics are used for different we can say that the use cases. That is what has to be demonstrated in front of the students. So such kind of things should be included in core AI layer. Coming back to the next one, when we done with the simple machine learning algorithms, next one is a neural network and deep learner basics we taught in this particular core AI layer. And then the introduction to the current trend, that is generative AI concepts. So all these things should go in this core AI layer here. So again, as I said earlier, when we talk about this core AI layer, it will give some technical depth and the reasoning. The students can reason like why this is working, why this is not working, why this metric should be used on so and so data set, why I supposed to use this particular algorithm, why this particular model is failing on this data set. So such kind of reasoning is possible if I include such kind of things in the second layer. So that is what the takeaway over here, why the model is works, not just how to run it. So right now what is happening is the people know how to run that particular model, but when we ask, how did you got 98% of accuracy on this for this particular use case, the people are not in a position to answer that particular question here. So that's a reality of the current things here. So I'm not saying about every student. If you talk about the student in large, the many people are facing this kind of things here. So we should, of course, we have to design the curriculum in this way. At the same time, we need to teach in that way also. So that's another thing comes here. The last layer is something known as the applied layer here. Um, this is where the learning becomes the real, basically in the artificial intelligence. Because the purpose of this layer is to bridge the theory with the real world problems here. We used to teach theory. We used to give some, we can say that kind of problem definition or standard problem definition, which does not have, we can say that messy kind of things. They are clean kind of problem definition used to give to the students. So that thing should not happen. What should happen over here is what should be there in this case is we need to include the real world problems so that we can bridge the gap between the theory and the real world problems over here. Prepare the students for industry and research. That is the another very important thing when we done with the help of this layer here. So what should go here is the domain specific applications. So we should include the domain specific applications like healthcare applications, agriculture applications, or some manufacturing applications, finance applications, and such kind of things should be included so that the students will get some hints about the real world. We should include the projects. And when I say projects, it should not be the end project or something like that. The projects means the mini projects, capstone work or something like that should be included. That will be continuous process. That's the one more thing. Case-based studies from we can say that the industry. Very important thing is agentic AI system should be included in the curriculum because right now we are living in the era of agentic AI. So if we don't include the agentic AI in our AI curriculum, definitely we are can say that 5 to 10 years going back, and we will not be able to cope up with the changing artificial intelligence things and so on. That's the reason AI agentic AI system should be included. And finally, the very important thing is the deployment considerations. So right now, we used to come up with a model, but no one talks about the deployment. In the current, we can say that the syllabus or something like that. So we should have, or we should include the deployment considerations also. So these are all the points should go in this the layer here. The key design principle is contextual application and the decision making. So students should be able to design the contextual applications as well as they should be able to make the decisions. So that is what the main thing here. This layer emphasizes on you can say that the AI how we use AI responsibly in real world environment. So these are the three main, we can say that the layers, what we should use while designing, you can say that our uh, curriculum and all. Okay, so one thing I just want to point over here. This is a kind of theoretical kind of session over here. So what I'm expecting is if anyone has anything to discuss, I'm not asking, putting you to ask the questions, but if you want to have some discussions, definitely you can unmute and you can have a chat with me at in between whenever you have to do some discussions and all. Okay, so what happened till now is we have discussed what are the three layers to be included while designing the curriculum. At the same time, what is required is we need to consider these things also, tools and platforms. This is the another thing to be included if while designing the syllabus. It is not about mastering a particular tool or something like that. So what I'm talking over here is whenever we talk about selecting an algorithm, selecting a model for a particular data set, at the same time we should be able to select a particular programming language also. At the same time, we should be able to select a particular framework also. We should be able to select the environment where we can deploy it. So these are all the things should be taught as and when the things are required in each of those three layers. It comes in each and every layer, not only the last layer, not only the first layer, or not only the intermediate. Ethics and governance does comes in almost every layer here because I think I have told many a times, ethics and responsible AI design is the very can say the primary goal of any AI engineer or something like that. It is very important because many of our lives depends on artificial intelligence systems because what they are using it for anything and everything nowadays. So that is the thing should be there. This accountability in AI decisions is the first when we talk about ethics and governance. What is accountability? That like when we design an artificial intelligence systems, they make some decisions, and we try to deploy that AI system in real world. And when make some decisions in real world, what happens over here is who will is responsible for those decisions? Whether the person who is using that AI system is responsible, or the person who has designed that particular system is responsible, or who is responsible for that particular thing. So that is the very important thing that comes in front of us. Think the best example for this one is the driverless car. So we can design a driverless car that's nowadays quite easy. But the thing is, when some accidents have happened, who is responsible for those accidents? Because there is no driver. And when you ask the owner says that I have bought a car which is driverless, so I'm not responsible for this accident. And when it comes to the manufacturer, he may say that I have designed it with so and so accuracy, so I'm not responsible. So who is responsible for these kind of decisions? So there must someone must be accountable. So that we need to include in the syllabus. The second one is the regulatory awareness. Each and every, you can say that the country has their own regulatory, you can say the laws and all legal things are there. So whenever we design as an engineer, we design an AI system, we should comply with those legal and regulatory frameworks. So it should not be the thing learned after the education. So what should happen is it should be a part of our curriculum. So we should include such kind of things in our curriculum so that we can understand where it is where it can be used, where it cannot be used, what can be used, what cannot be used, and all those things comes under this regulatory awareness here. Coming back to the next one is something known as responsible deployment practices. This means uh, how this AI is deployed is very important than how it is built. Because if you just build an AI system, that is not sufficient actually. What should happen is you need to deploy that particular model in the real world. But before we deploy, what should happen is the thorough testing should happen. That's a very important thing. If it is not tested with all the circumstances, definitely it will imply a lot of lives and all. Once it is deployed, the very important thing is the monitoring the behavior of that AI system is also important. At the same time, we need to avoid the misuse unintended harm, or you can say that the biases, all those things should be avoided. So what is required is while designing a curriculum, we need to include the deployment practices also. So how to test the AI model, how to test is not how to test, thoroughly test that particular model for considering each and every circumstances and deploy it. Once it is deployed, how to monitor that one, that should be included. And finally, we need to uh, include how to avoid the biases, misuses, unintended harm, and so on. All those things should be included when it comes to the ethics and governance. Uh, Now, the next question comes in front of us is whether, so these are all the things should be present as a part of our curriculum. That's the first thing I should tell you. I think we have discussed there will be three layers. The first layer is the this one. It starts with, you can say that foundational layer, core AI layer, and then the applied AI layer. These are the three things are there. I think I have discussed what should go in each and every layer. And in each and every layer, we need to include some kind of tools and platforms. What tool to be used, what tool should not be used, what is the platform should be used for building an application, deploying that application, and so on. And another important thing is ethics and governance should be included in each and every layer. It should not be a separate subject. It should be a part of each and every topic here. So that is what we have discussed till now. Now, one small question comes in front of us is whether this AI aligned with NEP 2020 or something like that. Of course, it does aligned with NEP 2020. The reason is uh, the AI is the skill-oriented learning, and NEP emphasizes on the skills over the memorization. NEP 2020 says the memorization is not so important. What is required is the outcome or the skills. What you will learn is very important. Application over theory is important in NEP 2020. The same thing happens in the artificial intelligence also. The next one is multidisciplinary course design. AI is a multidisciplinary. I think I have already told you. And NEP says, or NEP promotes the disciplines. Like they don't go with disciplines like X, Y, or Z. The interdisciplinary approach is introduced in NEP 2020. So the same thing has been followed in AI also, because AI is not restricted to a core computer science, core mechanical or something. It is interdisciplinary. So definitely it is aligned with what we can say that the NEP 2020. What NEP says is there should be experiential learning. There should be project-based evaluation. So, case-based learning, industry-oriented learning. So these are the things the NEP 2020 highlights. The same thing is there in our AI also. AI cannot be learned as a static subject. We need to do the experiments. We need to start with one model. We need to think about whether the model is good or bad, whether this particular model is giving justifiable results or not. If not, we need to fine tune it. We need to change the hyperparameters. We need to do some can say that hypothesis testing, this that and all we need to perform, and then we need to come up with the final results. So what it means is when we talk about the NEP 2020 and AI, both of them are aligned with one another 100%. The second one is whether the AI do justification to the outcome based education. Outcome based education focuses on what students are able to do at the end of the learning, not just what is taught in the classroom. So that's a very important point in outcome based education. What students are able to do at the end of the learning, not just in the classroom or what is taught in the classroom. So AI education fits naturally because it does follows the OB same framework here. Now, if that is the case, how the course works, course outcome, sorry, so course outcome should be defined over here. Uh, in course, while designing the course outcomes, uh, we can go ahead with, we can say that problem formulation, model reasoning, interpretation of AI outputs, ethical and responsible use of AI. All these things are part of our course outcomes here. Second one is the program outcomes. I think we have some set of program outcomes in NBA or any other, we can say the accreditation process or something like that. When we talk about the AI, the broader abilities of students develop after the graduation contributes directly to the analytical and critical thinking. So whenever they complete the AI education, they contribute directly to the analytical and critical thinking. uh, they use the modern tools to design the, we can say that the AI systems. So of course, modern tool usage is considered here. Lifelong learning skills they does inculcate over here. Ethical and professional responsibility, teamwork, and all those things are a part of program outcomes, and we do follow those things in AI education. So definitely, outcome based education is justifiable with respect to AI here. The thing next thing comes is the mapping. We can map the course outcomes to different things like problem analysis is the one program outcome, design and development is another one, modern tool usage, ethics, communication skills. We can map it to continuous lifelong learning. We can map it to, you can say that there's something called as team building, team learning, and so on. So we can map it to almost all, we can say that are uh, mm, the outcomes over here, program outcomes. So definitely it aligns with our what is that called as the outcome based education. The last one is a continuous improvement loop. Of course, it is there in everything, but in AI, everything is changing so rapidly that we need to learn on a regular basis. We need to reskill. We need to uh, reskill ourselves, and then we need to upgrade. That is the reason continuous improvement loop is followed in outcome based education. Now, what about Bloom's taxonomy for AI? So, what kind of label should be used in AI? That's the next point comes in front of us. When he talks about Bloom's taxonomy, which is highly relevant in AI education, uh, AI forces us to move beyond memorization towards higher order thinking skills here. In Bloom's taxonomy, we have, of course, all of us know this one. There were different levels are there, like remember, understand, apply, analyze, evaluate, create. So starting from remember to create. So there were six levels are there. Based on the kind of subjects or kind of question, we used to put them into one of these particular the science or something like that. When we talk about artificial intelligence, the lower levels are not necessary, or you can say that they are not sufficient in this case. For example, remember, understand, and so on. The reason is very simple. The AI tools are already doing all those things. They remember, they apply all those things they will do. So when we design the AI curriculum, our goal is to guide the students towards the higher order. You can say that the Bloom taxonomy, like analyzing, evaluating, and the creating. So some of the examples I will quote here. When we talk about analyzing, why did this model behave this way? So this is the analysis the people will do. The second one uh, is this output reliable? That is the evaluation kind of thing here. Uh, can the students design a better model or a solution? That is a create. So what we can do is we can think of AI in Bloom's taxonomy is at the higher order, not at the lower level, like remember, or you can say that apply or something like that. It goes beyond that one, like apply, evaluate, and create in this particular case. At the same time, we can map the AI projects to the higher order skills. The same thing goes over here also. So, what actually I'm trying to focus over here is like AI does align with the NEP 2020. AI justifies the outcome-based education. At the same time, the AI justifies the Bloom's taxonomy also. We can use the different levels like analyze, evaluate, and create in the AI schemes. Now, coming back to the things, curriculum revision cycle or something like that. So when you talk about curriculum revision cycle, what actually happens is curriculum is designed after every 3 year or 5 year or something like that. That thing should not happen. curriculum should be designed at a shorter span of time. If not, if we design the curriculum in a modular, flexible kind of thing, definitely we can add some points, we can remove some points or something like that can be done. But while designing the curriculum, a very important thing what to be considered is the industry feedback. We need to consider the feedback from the industry while doing, can say that curriculum revision, because what is happening in the current industry may not be aware to the faculty like us. Of course, a few of them may be knowing, but what is happening in the industry may not be known to everybody here. So that's the reason industry feedback is the very important thing while designing the curriculum. Uh, we will get to know what is happening in the industry, emerging skills required, what are the gaps the graduates have with respect to current syllabus and so on. So if you get this one, we can add the proper topics. So that's the reason industry feedback is very necessary in this case. Next one is the student feedback integration. Of course, not only the industry, we need to consider the feedback from the students because they know what they have learned. They know how it is, what extent it is useful for them in the industry and so on. So that is the reason we should include what I can say that the student feedback over here. Alumni can say that the input should be considered while designing the curriculums. Annual review mechanism should be considered at the time of while doing the curriculum revision and so on. So this is about what we can say that the curriculum. So what should go in curriculum, what should not go in curriculum, how it can be flexible on or the modular. The next part of our discussion is something related to pedagogy. Very interesting and very important thing over here. Pedagogy is it's not something different. It's a science and art of teaching. Okay, so when we talk about pedagogy, we talk about how should we teach a particular topic? How we should teach this particular code? How should we teach this particular diagram? So that is what the pedagogy is all about. It's a science and art, you can say. So I'll take a simple example. When you talk about, you can say that the AI educator and AI faculty, you can say that it should go from, we can say that sequential learning. They should give real problems and then they should give the theory. They should teach the theory. Then they should design the model and then evaluate. This is the we can say that the sequential learning should be followed over here. That's the one thing. So second example you can quote here is before teaching, you can say that neural networks, the faculty first assess the prerequisite knowledge of that particular thing. Like when we want to teach neural network, we should know, or we believe that the student should know the statistics. The student should know some linear algebra. So if they know, it's well and good. If they don't know, we need to teach that, and then we need to go to the neural network or something like that. So that gap should be bridge should be we can say that filled with some maybe the same classroom we can do it or some extra classes we can take or something like that. The second one is the pedagogy is learner centered. Nowadays, uh, everything is learner centered, not the teacher centered over here. The focus shifts from what I teach, then what student learn to what student learn. So that is the things over here. Students' active participation in learning is very important. Teaching adapts to the learner needs. We need to adapt ourselves to the learner needs, not what we know we should teach. So that's a very important thing. I'll take some of the examples over here. Uh, when we do, how can we achieve this particular learner-centered pedagogy is in a data science course, students are allowed to bring the sets from their own, and then such as traffic data, weather data, or business data, and apply the same analytical techniques. So that what will happen is we are not teaching; they are self-learning and we need to guide them. So that this thing should happen over here. Students should be encouraged to ask AI tools the questions during the learning. It is not that we should not ask them to think everything by themselves. We can use AI tools, but end of the day, what should happen is uh, we should leave them to learn. Not we should teach everything by ourselves. That is very important here. Learner-centered pedagogy is important. The next one is focus on learner engagement. The question is, how can we engage the students nowadays? That's a very difficult question, because the one who is engaged, one who is curious, and the one who is involved in problem solving, definitely he will retain the knowledge for a longer period of time, and he will apply it better. So what should happen is we should make the students engaged, curious, and involved in problem solving. Again, the question comes in front of us: how can we do that one? So what we can do in this particular thing is uh, we will give some during the AI class. What we can do is we can give the coding. Live coding can be done. Like we ask the students to come and code a particular program or something like that. We can conduct some polls. We can conduct some discussions within a classrooms rather than just going through the slides or something like that. That's the one thing. So how can we do it is there are some different applications are there. It's very difficult to spell. I don't remember exactly, but there is something called as Kahoot or something like that is the one. Kahoot. There is something like that. Second one is Mentimeter is the another one. With the help of that, we can conduct the polls. We can do the discussions on a certain topics within the classrooms. So what I'm trying to say here is, rather than just go on teaching what we know, we should include the students in the teaching, like conducting the live coding polls, discussions. Now, if you do this particular thing, what will happen is definitely students definitely will be able to increase the students' engagement in this case. The next one is the very interesting adaptation to diverse learners. When you go to the classrooms, it is not that everyone is at the same level. Some of them are slow learners, some of them are highly fast learners, some of them are fast learners, or something like that. So, what we should do is we should not teach the same way to all diverse learners here. Uh, for the fast learners, we should teach only the overview. For the slow learners, we should take some extra remedial classes. Somehow we have to bridge that particular gap. Then only what will happen is we will be able to, we can say that the match the diverse learners over here. For example, if there were a lot of advanced students or the fast learners are there, we give the open-ended challenges to them. For you can say that the slow learners or the beginners, what we can do is we will give simple questions and then guide them step by step so that they can go up to the advanced level. So this is how actually we can do it. Somehow that's the only option what we have here. The second thing what we can do in this case is recorded lectures can be shared with the slow learners or the beginners so that they can cope up with what has been taught in the classroom. Because if you go on teaching advanced topics in the classroom, they may not be able to understand the things. So what we can do in this case is we can record some lectures and we can put those particular lectures. Can say that we can share those lectures before they come to the class. They will go through those lectures and definitely they will come up with some knowledge. That's another thing we can do in the pedagogy. Technology as an enabler. So what we can do is we know the technology, whatever we have right now, is the supporting tool. Of course, we can use that thing in learning as well as teaching. So we should enable the students to use that technology and come up with. Can say that uh, come to the classes. It is not don't can say that restrict the students to use ChatGPT. Don't restrict them to use AutoML frameworks for designing the machine learning models. Don't restrict them to use the simulation softwares. But what we need to do is when they come up with the result, we need to check whether it's original or not. So can be done very simple. Like just don't accept the assignment. When we accept the assignments, we just go on cross checking whether it is done by them or not by asking simple oral questions. by asking them the process what they have followed to come up with this particular result and all. If you just go through this kind of things, definitely we can check whether it is original, or we can say that it is been copied from somewhere else or not. Definitely they can use, but while doing that particular thing, they should learn. That's a main motto of this thing. The pedagogy is about designing a learning experience that helps every student think, engage, and grow. The technologies simply support this particular process. So that is what actually the meaning over here. Uh, of course, why it matters is it enhances the conceptual understanding, encourages the experimentation, supports ethical awareness, and then the skill development. So these are all the reasons why pedagogy is very important. The next thing what comes in front of us is the shift is going from one way of teaching to the another way. So there is something called as traditional teaching, and there is something called as AI-centric teaching here. Again, before I proceed with this particular thing, we cannot replace the traditional teaching. Of course, the talk and talk method is required, but in some of the cases, we can include this AI-centric teaching so that we can bridge the gap between traditional to AI. So that's what actually the meaning over here. So it starts with what is that called as the lecture based in the earlier case. Nowadays, what is required is experimental and interactive. We can say that teaching is required. So when I say lecture based, we will be preparing a lecture, we will be preparing some PPTs, and then we will presenting in front of the students. But nowadays, what we need to do is rather than just going through that one, we need to give what is that called as some problem, and we need to do some experiment on the top of that particular problem and come up with the results. So that is what is about experimentation. Simple example for this particular thing is we can give some data sets, and then we ask students to do the exploration of that particular data set and analyze what particular, you can say that the model is suitable for that particular data set and so on. So such kind of things we can do. The second one is something known as theory based teaching. Rather than that one, again the same thing, problem and project driven things here. So we will give some problems, and then we will ask them to come up with a final product, and the process also. That's a very important thing in this case. Now coming back to the next one is exam focused was the traditional teaching method. Nowadays the continuous assessment is required over here. What is the meaning of this particular thing is uh, when we talk about continuous assessment, we need to understand the process they have followed rather than the final output. That is a very important thing, because the final output can be generated with the help of chat GPTs and so on. Not Gemini will give the complete product, but what is the process they have followed? Whether they have understood the data set, whether they have understood how the data set has to be pre-processed, or what is the implication of a particular model. If they have understood that particular process, then it is quite good. Individual learning to collaborative learning. In the earlier days, the individual learning used to happen, but nowadays that is not sufficient. We need to prepare a group. We need to divide that particular task into multiple groups, and then each group will should come up with the result, and then we need to amalgamate, and finally we need to give the result. The earlier was a static syllabus. Now everything is evolving every now and then, so we need to have an adaptive curriculum is very important. Tool avoidance was the thing in the earlier case, but responsible AI tool usage is very important. In the earlier days, we used to say that don't use this tool, don't use that tool, don't use this particular simulation, and so on. But nowadays, we need to use that particular tool, but very responsibly. So we need to guide the students for that particular thing. Along with all these particular pedagogies, what we can do is we can use something known as the flipped classrooms, where we can pre-record their lectures can be given to the students, and then they will go through that particular concept, and then they will prepare for that concept and come to the classrooms. In the classrooms we can do the live discussions and so on. So that is another kind of thing we can use. There's something known as the flipped classroom, which will encourage the self-paced learning also. The reason is when we give pre-recorded lecturers, or can say that some kind of content, if he's a fast learner, he will go through those recorded lectures in a very short period of time. If he's a slow learner, it will take much time. But end of the day, they will go through their learning process, and when they come to the classrooms, we will have the live discussions and so on. So that will what will happen if I do this one is it will definitely increases the student engagement, their involvement in understanding the concept, their involvement in solving a particular problem. So when they do all these things, definitely it will remains in their mind for a longer period of time, and they can apply this in real world also. So that is the advantage of having flipped classroom pedagogy in this case. And the last very important kind of thing is we need to include agentic learning. If I don't include this agentic learning, as said earlier, we are going 5 to 10 years backward. That thing should not happen. We are living in the agentic era, so we have to include agentic learning. Like, what is an agent? What is an AI agent? What is agentic AI? How to build agents? How to build agentic AI systems? How those things are making autonomous decisions? These all the things should be included, and these all the things should be considered as a part of pedagogy. If that is the case, definitely the students will understand the things in clear. Coming back to the examples for agentic AI, I think we have discussed one thing in the previous classroom, like agentic AI we were trying to build. I have shared that particular PPT. I think we can follow that PPT to build that model very easily because each and every step has been included. Today, I thought I should go with that thing one more time, but I don't think we have a sufficient time. We'll see what can happen. But that is a very important thing. These are all the some pedagogies. What we can do is we can follow in our classroom. So I think I have discussed. These are all the things: experiential, interactive, problem and project driven, continuous assessment, collaborative learning. We need to adapt to the evolving. You can say that AI responsible AI tool usage should be considered as one of the pedagogy, flipped classrooms, and then agentic learning. These are all some of the pedagogies to be considered when we teach artificial intelligence subject. This is about curriculum and pedagogy. The next part is something known as assessment. Why assessment of AI is difficult? That's a very important question here. There is a plagiarism risk. I hope all of you are agree with this particular thing because nowadays when we give some assignment, people put that particular thing in one of the generative AI. They come up with the results in a fraction of time, and then they will reproduce the same thing in front of us. Problem here is uh, whether that particular thing is original or not. It's verifying that one is a very difficult task. In the earlier days, we use the different plagiarism tools like Turnitin, this Authenticate, and all, where similarity index or text matching was done. But nowadays, that is not sufficient here. So, what is can be done in this case? To check originality and all. Whenever someone has submitted something, maybe code, maybe assignment, maybe anything, maybe any activity report, we have to test it for originality. So one thing what we can do over here is we can ask the process what they have followed. If they say that we have given the prompt, we got the result, and this is what the thing, then definitely they have not learned. Of course, they can use this AI tools. I'm not against AI tools, or none of us are against, not against again this AI tools. But still, they have to learn through that particular process. So that is what is required. We need to ask the process. The second thing is ask some questions, general questions. With that, definitely we will get to know whether it's original or it has been copied from somewhere else. That is what I said. Tool dependency is required, but the tool should not become the student here. That's very important point I can make here. Tools should be used, but the tool should not become the student. Like ChatGPT should not become the student. The student should remain student, and they should use this tool for their learning purpose. So that is the thing. What I wanted to make over here. The rapid evaluation of AI tools is the reason for all these things. Every now and then we get different AI tools. Because of that, all these kind of things are happening. But definitely we have to test for originality. The only solution for that one is we need to ask the process. What is the process they have followed? What is they have learned can be understood by asking some simple questions and making them to answer and you should go on and asking some different questions. So not just accepting the assignment and we need to do something like this. Uh, as said earlier, the AI assessment should be continuous. It should have some rubrics. It should have process-oriented evaluation, as said earlier, and reflection-based component should be there. So these are all the things. We can use quizzes uh, every now and then in a single class or every classroom. We can use the quizzes so that we can understand how they have learned. I think I have said some of the tools like Kahoot we can use or Mentimeter are the tools available. They are free of cost. We can design some quiz and then we'll ask the tool people to take the quiz. We prepare some polls. We can prepare some discussion tools, and then we will be able to test the students' understanding. We can give assignment, but don't accept the assignment as it is. Ask the process. Projects, mini projects, final year projects, or capstones or something like that should be given every now and then for each and every, can say that, at least for the modules, to understand whether the people are getting the knowledge or not. Viva was presentations, Viva was and presentations, portfolio based assessment. This is another very important thing. Like the people should uh, do the thing, create their own portfolio, like what they have, from where they have started. They have started with the problem definition. They have collected the data set. They have done some pre-processing, whether they have done something else. So they have to maintain that particular portfolio. If that is the case, we will be able to understand whether what is the process they have followed to come up with the results here. So when I say portfolio, it should not be same for everyone. For example, some of them may be failed in data sets selection. Some of them may be failed in what we can say that model tuning. So all those things should be included. Some of them may have trained it for only 15 epochs initially. That was not sufficient. They have trained it for 100 epochs and it was overtrained. They come back to 50 epochs. So something like that they have done. Each and everything should be, you can say that, included in this portfolio based assessment. So this is a very, I can say that, effective way of assessing the AI. We can say that the AI results in that particular case. So weightages, I am not going to put this one because it depends on the different kind of courses here. The second one is the rubric based evaluation. Rubrics are kind of, we can say, tabular kind of structure, something like this. What will happen with the help of this particular thing is we will be able to design some kind of, can say that, the way with which we will be able to analyze the certain topic. I have designed it for, it's not a complete or you can say rubric based. It's just a sample thing. I have prepared it for the project evaluation. So that you can define some different levels like excellent, good, satisfactory, and needs improvement. We can define the criteria like problem understanding, data pre-processing, data preparation, model selection, reasoning, such kind of things you can design over here. And then you can design some of the points like this one. Clear problem definition, strong context, real world relevance. It's excellent. At the same time, if something is there, problem defined, but context is partially clear, we can go with the good. Similarly, problem stated, but weak relevance, go with the satisfactory. Something like that we can design here. So again, I have designed it for each and every point. Again, it is with respect to my, I can say that the understanding. What is required is for all everything we can design something like this, rubric based.
Uh,
When we design something like this, we will come up with, we can
Right,
say
sir.
that,
Right, sir. Sorry for disturbance.
yes,
Uh,
sir.
Actually, from 6:30, test link will open, sir.
Shall I
Uh,
take another 5 minutes, sir? So I will close.
okay, sir. No issue, sir. No issue, sir.
Okay.
Just intimated that, sir. That's it.
Okay,
From
another 5 to 10
6:30.
minutes. I will put the closing
Okay,
comments, sir.
sir. Okay, sir. Test link will
Uh,
open.
oh,
That's it. Okay, sir. Okay.
it will be available, or it will close, sir, immediately.
No, sir. No, sir. From 6:30, it will start. I think participants will, I think, think about it. That's why.
Oh,
Just
okay, sir.
intimated.
I'll do one thing, sir. I'll put a closing comments and then I will put
Okay.
it, sir.
Thank you, sir. Thank
Okay.
you.
Yes, sir. Okay, so what I was talking is like rubric-based evaluation. You can design something like this for each and everything. It may be a quiz or assignment or your project or mini project, whatever it may be. It will give a clear guidance to the students, like what is happening, where they are lacking, what they have to improve, so that they will come up with a better grades or something like that. So this is again for every topic, it should be different things. Every can say that university or college should have some AI usage policy. What to be used, what where AI should be used, where it should not be used. They should have some kind of things so that the students will have a clear understanding, like where I should use this one, where I should not use it. What are the ethical constraints are there while using this one? This kind of thing should be displayed here and there, so that what will happen is students will not face any issues at the later point of their career or something like that. So we need to teach all these kind of things. So I can see here, these are some of the things I have listed, like where they can use it for brainstorming ideas. Just to give an example, uh, they can ask the chat GPT like, what I can do with respect to agriculture things. The chat GPT will give some certain options, like you can do a project in so and so areas or something like that. Out of 10 ideas, we can select one idea and then we can start building the things. Again, we are not building it everything from the things, but we are taking it from the help of AI tools. So we are brainstorming ourselves so that we can get some ideas. So we used to do this one with the help of Google in the earlier days. Now we are doing it with the help of AI tools. That's it. So code debugging, where we can use it, drafting outlines and summaries. So before we writing a paper or a report, we ask the AI tool to give the outline of that particular report and so on. So these are some of the things. I will share this PPT with the sir so that you can read it. These are some of the places where it is not allowed or something like that. The responsible AI education is very important, like the fairness in designing the AI system, trustworthy of AI system. When I say trustworthiness, it's very difficult to build a trust for a particular, you can say that the thing. Many of us used to buy, I can say that when it comes to TV or something like that, we used to buy a Sony or something. When we want to build any, when we want to buy any camera or something, we used to look for Carl Zeiss cameras or sorry, lenses or something. So they have built a trust over a period of time. So we have to build that particular trust. Now, how can we build? That should be a part of our education. The very important point is like infrastructure requirement. When we want to teach AI, there is a need of computing power. Maybe I can say that CPU, GPUs, memory, this, that, and all. Data storage requirements are there. Internet is required. Softwares and platforms are required. Data access, governance, all these things are the need of for the day. Without this, we cannot teach the AI. So all these things should be satisfied by the colleges or the universities. Last one is very important. Faculty support infrastructure. So somehow we should be able to upskill the faculties by conducting some FDPs, trainings, asking them to visit the industries. It is not just asking them to visit the industries. What should happen is we should give the financial assistance also as a college or something like that. Certification should be made compulsory. Should some I can say that encouragement should be given from the colleges or universities. So that's another thing. So industry integration is the another thing. Like we can do mini projects from the industries, asking the industry people to come to the college and give some guest lecturers, conducting some internship for the students in the industry. This is another thing what we can do. The very interesting point, what I wanted to do here is we can put the rural challenges and the social challenges in the curriculum because when people are connected to the rural and the social challenges, definitely they will come up with a better results or better AI systems. So that's what I can feel here. So, what are the final thoughts from my end is teaching AI is preparing students for uncertain futures because what is happening nowadays is very difficult to predict. So we don't know what will happen 5 years down the line or 10 years down the line because AI is doing a lot of things. Whether AI is a bubble or AI is a reality, that is also another thing to be considered. Uh, we need to make sure that the students are prepared to answer such kind of uncertain futures. At the same time, the faculty are the key to change this particular thing. So without faculties, this will not be possible over here. So this is from my end. I think I have divided this session with what is AI, why AI is required in our curriculum, and then I have started with what are the different layers of curriculum, pedagogy, assessment, and these are some of the things I have considered in this presentation. Uh, I hope I was able to give some justice to this particular, you can say that the session or the topic. Definitely, it was a bit theoretical, but I hope I have given some examples so that you can inculcate those things in your, you can say that the daily classrooms. Definitely, we can make these classrooms interactive or something like that. Uh,
Okay, sir.
Before I close, if anyone has any questions, they can put. Otherwise,
Uh,
uh,
Participants,
the
you can unmute yourself and you can tell something about the sessions. So as a feedback at the end, you can tell something about the present FTP.
sir is asking about entire all 13 sessions, if I'm not wrong.
Yes,
When
sir.
it is a
Yes, sir.
feedback, if it is all 13 sessions.
Yes, sir. I just
Yes, sir.
requested, but
They may be busy with exams, sir. I think you said like test link has opened at 6:30, I think.
yes, sir. Yes, sir.
Okay, sir. Okay, no issues. I will share this PPT once again, sir, because I think I have shared it, but I have done some changes. If required, we can share with you the students, not
Sure.
students actually. These are the teachers actually.
Yes, sir.
Uh,
Sure.
yes, sir. Yes. I will share my contact details. If anything, or if anyone wants to connect, definitely they can connect with me at the latest stage, sir. Thank you.
So thank you so much, sir. Thank you.
Thank you. I should thank you, sir, because you have given me this opportunity. At least, actually, you have given two sessions to me in this FDP. I should be thankful for you for
You're,
giving this opportunity uh, to share my ideas. I'm not saying that these are all not known to the other things, other people are not, but I'm trying to put everything in one structured manner. That's the only thing I have did in this particular session. Thank you once again, sir.
you're welcome, sir. You're welcome, sir. Thank you, sir. Thank you.
Yes, sir. Thank you, sir. So, shall I leave the
Yes,
meeting
yes,
or?
yes, sir. You can leave, sir. No issue, sir.
Okay. Thank you very much.
Thank you, sir. Thank you. Dear participants, I think the link is open now. You can before taking that test. So I would like to wind up this FTP. So first, I would like to say heartfelt thanks to all the participants. You were with us for 6 days with a good participation number. So first, no, I would like to thank God for smooth conduction of this event. Next, I would like to thank you people, that is participants. Next, I would like to say thank to all the resource persons. So they were in time and they engaged all of you people with some good stuff. Okay, I can't say anything more than this. After that, I know I would like to say thanks to our principal sir, Dr. Murali S, and our college management, and I would like to thank our HOD, Dr. Hemant Essa, and I would like to thank my team, that is our department faculties. So now, if anybody wants to tell a few things about the FTP, just you can tell. Otherwise, I'm going to end this session.
Sir, good evening, sir.
Good evening, ma'am.
All the sessions were highly informative, sir. Like the resource persons were all of high profile, and the KT they have done is like, it's really very helpful, sir. Thank you so much, sir.
Thank you, ma'am. Thank you, ma'am. Okay, let us end the session. Please, engage yourself with attending the test. And those who have not completed the feedback, please do it. And after that, you take the test. So thank you all once again.